video.
Итак, наш первый блок будет.
Our first block will be on the network security. We will talk about various aspects of security, and we will start with a traditional routing protocol, BGP. And I want to welcome here Alexander Azimov from Curata Labs. His presentation is titled The Best Protection is an Attack. Best Defense is Offense. If you have questions, please save them until the end of the presentation, and please also introduce yourselves because we are broadcasting online, and I will remind the speakers that they need to try to fit into the allocated time slots. Good morning. My name is Alexander Azimov, and I'm from Curata Labs. Today we will talk about the BGP anomalies, not about how to detect them, but what to do with them if they have already occurred. Well, first of all, why BGP still is a concern? Well, first of all, other people's mistakes affect our networks. BGP hijacks or route leaks actually are two anomalies that have much in common, but they are different. Both anomalies result in illegal rerouting of traffic, which results in higher latencies, unavailability, and man-in-the-middle attacks sometimes. So what concerns us here is that we are losing traffic, we are losing end users, and potentially we are also losing money. Anomalies originating in one region can affect traffic in another region. There are many examples like that around. This is an anomaly that originated from Nigeria, but it hit Google, YouTube included, and CalFlag. The era of the local operator route leak was received by China Telecom. China Telecom did not set correct filters. After that, it was received by Trans Telecom in Russia, which did not set the correct filters. After that, it was received by NTT. IRA1, and then it went out around the world. And as a result, the Google services, according to some users, were left partially unavailable in a number of regions of the world. What does it tell us about? Well, in fact, how much is a 30-minute unavailability cost? Of course, it depends, and the answer should be obtained on a case-by-case basis. There are business models that allow us to understand that, well, even if we are down for 30 minutes or a whole hour, it's okay, we can withstand that. But for some companies, unavailability for even 15 minutes will lead to serious reputational and financial risks. So for the companies for whom this is really a problem, any possibility to reduce the downtime is a desired objective. Let's discuss how we can fight that. We'll start with the leaks. A route leak, by definition, emerges if the operator announces a network received from one supplier or peer to another supplier or peer. We cannot, from inside Autonomous System 1, control Autonomous System 2. Changing policies on our side probably will not affect the situation very much. Not much can help, but I don't think that all of you saw the Hollywood movie where big monsters were fighting big robots, and there was the slogan, to fight monsters down, we had to create our own monsters. Maybe it's not the best tagline, but to fight the route leak, we need to kill BGP elsewhere. We need to break it down. If we add Autonomous System 2 at the start of the path, it will lead to the situation when we receive this announce, we will be protecting the BGP from the cycle, and Autonomous System 2, when it receives that error, it will discard it to break down the leak and get our traffic from it, we need to apply the so-called path manipulation technique. Is it totally legitimate? Well, it depends on the point of view, but in any case, you are not attacking. You are saving your own traffic from the black hole, and I think that in that particular scenario, our actions are fully justified. So with the leak, it's easy. It seems to be quite an easy solution. What about hijacks? Actually, you can do more about hijacks, but all solutions are much more complicated. It depends on the type of the anomaly. If it's a more specific conflict, the other party announces a less specific route compared to our space, probably will not affect our traffic. Maybe it will hit some of the operators that are not using full routing tables. But what if it's a peer or a more specific route? Well, of course, we can try to return the traffic to the maximum of our ability. We'll be able to make more specific announces. We'll be able to use prepends, or origin IGP, but the other party can also announce /4, and then it will be a race. Some part of the traffic will be received and some part of the traffic will be lost. What other options are available? Of course, we can sit down and start writing emails to someone who committed this anomaly, to someone who is used to disseminate the anomaly. Actually, although this picture is kind of pathetic, if you have an hour or two, most likely you'll be able to solve your problem with emails. But it works if it was truly an error. But if you do not have 2 hours, or it's not an error, but it's an attack, in that case, you can solve. It can take up to a week to solve this problem with full support of the community. So, what are the technical means that we can apply to fight hijack? Hijack, on its own, is rerouting of the traffic. So, what we're trying to do, we need to return it back to our network, bypassing the anomaly. We need to minimize the risks, even if we can't fully avoid them. The more connections we have, in theory, the less the attack will expand. So if we connect to all sources of traffic, even if the attacker announces whatever is announced, there will be no hijack. But there is a problem with this. In Russia, there are a lot of operators. And some will say that it's a good thing, but in that particular scenario, it turns out to be a problem. We counted the distribution of users per one traffic filtering network. It turns out that 10 largest telecom operators in Russia cover about 30% of the networks. To cover 80% of access networks, we need about 400 operators. 99% of users are covered by almost 4,000 operators. So if we need to fight hijack, and for this we have to connect to all of them, and well, you see that very quickly this task becomes unrealistic. We need to optimize this number. The question is how we do it. So we used modeling. We created a virtual wall. We took an abstract virtual operator. At point 0, it's connected only to Msk-Ix. And then 60,000, there are 60,000 autonomous systems, and from around the world, they attacked our virtual operator. So we looked through which transit operator most of the traffic is going, and at the next iteration, we use this operator as the new provider. So at every iteration, we mitigated the risks. For those of you who love math, I suggest that we discuss this offline, but now, I mean, the method itself, but now let's turn to the results. This is the risk distribution picture. As you can see, the optimal choice of a transit operator at early stages can reduce the risks significantly, but subsequently, the more operators we add, the less risk mitigation happens. So the question is, why does it happen? Here is the reason. The worst attackers are those who have good peering coverage in the regions. And unfortunately, there are a lot of operators like this in Russia, not only big ones, but a lot of tiny ones who have a significant presence on a number of IXs. And in that particular case, our announcement and the announcement from the attacker have the same path. They have the same priority because both of them are peering connections, and they are equals. And the choice of the operator is really like using a coin to decide. It's like 50-50. 50% are the chances that we'll get the traffic, and 50% are the chances that the attacker will get the traffic. So what are the solutions? RPKI and ROA validation. What are they? Well, in particular, ROA validation is the new way to filter announcements that allows us to identify illegitimate pairs of prefixes and autonomous systems. How does it work? We identify the rightmost autonomous system, and after that, we identify a set of candidates that will cover our prefix. And if there is a match between the autonomous system on the path and in the ROA entries, then the entry, the record, is valid. Or the path is valid. And if there is no match, then the path is invalid. In accordance with RFC, all invalids must be discarded. How does it help us? In this case, if our peering partner has RPKI, our partner will discard the path received from the attacker. If the attacker, moreover, tries to bypass this protection using IcePath manipulation that we talked about when we spoke about leaks, it will also be discarded. But actually, the alternative path will become longer and it will be less a priority. But how many operators do we need who support RPKI in order for us to mitigate our risks? And here, mathematical modeling comes to our rescue. We did counting. We imagined a world where RPKI and ROA validation is supported at the Moscow Internet Exchange and at several transit networks. They're written here, Rostelecom, Transtelecom, and the big three. You can see that just supporting RPKI in those networks mitigates hijacking risks significantly. Another interesting thing is that even if the attacker tries to bypass this defense, it turns out to be not very efficient, and with many connections, the efficiency results to be lower than with direct hijack. So the solution is quite simple. We need RPKI. You need it in order for you to lower your risks. We don't need to deploy it across all of the Russian network, across all our ASs, but we need only several key points to deploy it. And it's in your hands, basically. So that's the main takeaway from this presentation. It's in your hands, and I'm sure that many of you work with those providers, and sales managers are still sleeping. They will join us a bit later during the day, but it means you have time to get ready, and during the next coffee break, you can find them, you can catch them unawares, and you can start asking them and demanding RPKI in their networks, because it's in your interests primarily. And of course, you will have to subscribe your address space with ROA. If you haven't done it yet, you can use Visa, and it will take like 5 minutes for you to complete the task. But we have a very efficient way to combat route leaks, path manipulation. AS-path manipulation is 100% guarantee. With hijacks, it's slightly more complicated. We need RPKI deployed in major networks, and unfortunately also for the networks who want to improve the security, we need, they will need to invest into the infrastructure. So on the one hand, investment. On the other hand, the risks. So if the risks outweigh, and if half an hour downtime for you is a major financial loss or reputational loss, I think the choice is obvious. And again, the ball is on your side, and it's up to you to take that decision. Thank you very much. Your questions now, please. Don't hesitate to ask questions. Well, if you are too shy to ask them now, you can get our speaker during the coffee break. Okay, if there are no questions, Alexander, thank you very much. I have another question to Msk-Ix. When are you going to deploy RPKI? I will talk about this today after the lunch break. Please come to that session. Thank you. And since we are on the subject of RPKI, I think that, well, it's a good topic to discuss. Let's go into more details of it. RPKI is a process in a way, and I want to invite Alexander Venedyukhin to brief us on RPKI deployment. Good morning. My name is Alexander Venedyukhin, and I am here representing ИнДата, the Foundation for the Development of Network Technologies. We research the address space, we research the services, and Alexander's presentation actually, from it, he learned everything you need to know about RPKI. What I enjoyed very much in what he said, let's kill BGP in one place to benefits another way. So I think that RPKI is breaking virtuously the BGP to obtain benefit elsewhere. I think that potentially the problem is you will not be able to announce to the one who you want to authorize the announcements of the prefixes, but you have to subscribe everything correctly and monitor the subscription. I wanted to share some statistics with you, not only on RPKI, but also other technologies, security technologies, IPsec, for instance. I'm sure that all of you are using SSH. I will not go into details of those technologies. I'll just mention them, but I'll talk about DNS and SEC and other technologies that share, say, the same encryption, cryptography. In the title of my presentation, you see the word slope, and there are many slopes and on the graphs, on the curves in my presentation. I'll try to not to overburden you with the graphs, but okay, let's get down to the presentation. I'll start with TLS. In terms of the volume of traffic, TLS in the internet is the number one or somewhere among the leaders. Here you see TLS penetration in terms of HTTPS. The 443CP for the .ru domain, but .ru is our leading domain. You can see here that it's growing strongly from 2015 in just 3 years. Its penetration, TLS penetration in HTTPS amounted, the growth rate was about 20-fold, if I'm not mistaken. No other technology has grown at that rate. I promised slopes here. It's a good slope here, and not a stepwise a slope, but a regular slope. But if you change the scale, you will see that we are about to climb another step. If you consider TLS deployment since 2008, back in that time, TLS was quite an exotic technology. Very few web nodes used it, and for many years, it was not growing. It was on a plateau. And then around 2014, suddenly it made a leap forward, and now we are, again, like I said, climbing that new step of the ladder. And after which I expect the technology to plateau again. About 650,000 web nodes in the .ru zone are using TLS for HTTPS, and we believe that this number is close to the number of active websites. There are about 4 million sites, if I'm not mistaken, in the .ru area, but you have to discard all satellites and other forgotten and lost sites, and it means that we'll be looking at 800 and 900,000 pieces, and 650,000 are already supporting TLS on the HTTPS, and it means that there isn't much growth opportunity left, and it means that the technology will plateau, and it's an interesting situation which will benefit RPKI. And this graph shows you how a new technology is adopted. So no technology, then it is slowly adopted, and then it's quickly adopted, and then it flattens out again. So what are the reasons for such a leap in the adoption rate? Around summer 2014, Google said that they will be ranking the websites who support HTTPS correctly higher. And of course, everybody wants to be first on the first page of the Google search, and that supported the technology. And also browsers joined the campaign. They started sending out warnings that HTTP in the next versions of the browsers will be identified as an unsecure protocol. And now you know that this has already happened. The majority of modern browsers are already identifying, labeling HTTP as a non-secure protocol, and they send messages to the users to not enter your passwords here, etc., etc. And all of this, of course, backed the penetration of the technology. Another thing, a more technical thing, I guess, there is this company, Cloudflare, and at a certain point, their front ends implemented automatic HTTPS. Everybody who hosts with them can click a button and get HTTPS. You could see this from statistics. Immediately, the numbers started climbing up because they host a lot of users, and suddenly all of these users acquired HTTPS. And the same was done by other hosters. That was a major contributor. And the third driver actually probably was a greater weight. Probably you heard about Let's Encrypt. It's a free certifying center. There used to be more of the certifying centers in the past, but now there's only Let's Encrypt. It's not just certifying center, but you can issue and reissue those certificates automatically, and it's a good parallel with RPKI, where you can use a similar RIPE NCC service without really thinking much about the process. Everything's been taken care of. Let's Encrypt is the leading certifying center in the .ru, and its next competitor, which is Komodo, I think is 10 times smaller. Most of the websites are signed with Let's Encrypt, and that's it. DNSSEC. DNSSEC is an interesting technology because its fate is similar to that of RPKI. DNSSEC and RPKI are both quite old technologies. Everybody understands them. Everybody agrees that they're useful, and nobody uses them, in fact. If you look at the DNSSEC adoption curve, you'll see the steps here, like on a ladder. Only the numbers are kind of unsatisfactory. If you look at the left top corner, you'll see the number 3,000, and there are about 5 million sites in the .ru zone. So 3,000 is very little, but it means that it has an excellent potential for growth. Just forget about the numbers, because we are interested in this step like adoption rate. And to the right is we see exactly what we wanted to see. Is suddenly there was a surge in penetration, and this technology has a good chance of conquering the whole zone. Again, we need to. I remember Cloudflare, on the authoritative resolvers, they support DNSSEC, and as soon as they fixed the issues with certain algorithms, immediately DNSSEC was available in the zone, and we saw the growth. In parallel, major registrars, several major registrars, Regru, for instance, they also, for their customers, implemented a feature where the clients could subscribe the zone with just one click. So all of this, of course, supported the growth. And there is also a side effect when some major players implement DNSSEC. They publish that information in the news. Mass media writes about it, and even if people are not using the services of those companies, they read about the DNSSEC and they say, yeah, okay, let's have it too, and then they have it. Of course, this statistics is based on DS records without validation. Out of TLDs, recently I saw the statistics. .bank, it turns out to be a leader in broken DNSSEC zone. For .bank to delegate the zone, you need to be able to support DNSSEC, and it was a leader. I don't remember. I think 1/4 of all broken. 1/2. People are telling me it's 1/2. 1/2 of the zones was broken there, but originally .bank is the safest domain in the world because it's used for financial transactions. And RPKI, finally. Recently, we started monitoring RPKI statistics, and we looked at the graph, and it looks very similar to DNSSEC. It's similar in terms of rather modest numbers, so I'll hide them because that's the top of our curve. And I understand I'm manipulating the scale because we are looking now under a microscope. We've zoomed into this graph and we see the steps, because steps are what we really hope to see. If you can read it, it says, and this is where Wilkins hit the seismographer. So we looked at this RPKI growth curve together with colleagues, and we thought that probably we have these steps of the ladder just because somebody accidentally hit the tool. We can't say really that there is a new technology that we didn't have in the past, and now suddenly we have this wonderful technology. All the tools have been around for ages, and I mean, what can be the reason for it? We analyzed this picture that we love very much, and we thought, how about a RIPE meeting? How about different events? A search after a RIPE meeting. I'm making a presentation about RPKI. Somebody made a presentation about RPKI at a RIPE meeting. Everybody agreed that it was an excellent idea, and everybody rushed to subscribe. We saw a peak. So we want to ask you now to support our hypothesis. Please, and we agree with Curator Labs, please subscribe the prefixes so that we'll be able to see this leap on our graph at the time of the Pirion Forum. On our side, we commit to following the case, following the story, monitoring the statistics, and then after 1 year, we'll be able to confirm that Pirion Forum made its contribution into RPKI adoption, and then BGP-SEC maybe will emerge finally, and will be able to overtake DNSSEC, because domain administrators, whoever they are also subscribing whatever they have DS records, and network engineers have always been much more disciplined, and we can get ourselves a very impressive curve when we subscribe the prefixes. And if we subscribe the prefixes. I'm done. Thank you very much for your attention. Any questions? My name is Alexander Simov. A quick comment. BGP-SEC most likely will never emerge. We'll never get it because it's very heavy and it's complicated, but RPKI objects will still make use of them, only differently. there will be a new object that will be lighter than BGP-Sec, but it will do basically the same. For this, we'll need RPK objects. Okay, that's fine. I don't care what comes around, but I believe in the fact that the best things are yet to come. I agree with Alexander. BGP-Sec is dead weight. Because, I mean, the resources and the deployment, there is not a single vendor who has a correct implementation of it, so I don't think that it has a future, really. Okay, thank you. Okay, let's thank our speaker. And I have several organizational announcements. You must have noticed that our screens maybe are not easy to read. I mean, the screens that are behind the speakers, but there are also big screens on the walls. If you need to, get the tiny details there to read the tiniest font, you can look at the big screens. We also have Wi-Fi here. Extreme is the provider. We thank them very much for supporting the system and for the hotspots. So please make use of our Wi-Fi network here. And on the subject of security, we talked about protocols. We talked about RPKI. But equipment, hardware, that also makes a difference. So let's talk about how we can protect the routers from possible threats. I want Kirill Malivanov now to make a presentation of how we can protect the control plane. Hello. My name is Kirill Malivanov. I am from SelectTel. I will not talk about various SECs, BGP-Sec, DNS-Sec, and other encryption techniques. We'll talk about hardware. What about hardware? So we have a router, and we think now that we are a provider, and we will manage a lot of traffic. So we buy hardware. A router has a chip through which all traffic goes, and there are incoming and outgoing interfaces. So what can be wrong? We augment the traffic. Now we have a lot of in and out interfaces, and then it becomes different. There is a traffic that goes to the CPU of the router, and for some reason the CPU is bad. Only in the last several years the routers are equipped with Core Quad or Quad Core or Xeons, but in the past we had all the weak CPUs. I remember even CPUs of 160 megahertz in a router, and yeah, they worked, but they worked only until the traffic would not exceed the capacity of our CPU. So if we overload our CPUs on modern routers, what happens? If everything is okay, the CPU is not overloaded, the traffic goes through this hardware chip. Here is a hardware router. What can happen to me is hardware, but some traffic still comes to the CPU, and we see the surges in the workload of the router CPU. As soon as the CPU of the router is overloaded, BGP sessions are broken, PFP sessions are broken. I mean, anything could happen. What traffic can actually get to the router's CPU? Well, any kind of traffic, in fact. The traffic that we expect to get is the traffic of BGP and OSPF, because BGP and OSPF are daemons, and they live on the CPU, and everything is fine. For FLS, LDP, RSVP, ISIS, they also go to the CPU. We need to work with our router, so it means it has SSH, SNMP, radius NTP, and then suddenly ARP and IPv6 neighbor discovery protocol, for instance, suddenly it also somehow occurs on the CPU. And if HTTP relay is set up on our web router, it may surprise you, but it will also go through the CPU. And GP snooping and activating, deactivating groups, GP leaf, all of this also goes through the central processor. And if our router or the switch are parts of STP domain, STP traffic can also be processed with the central processor. An unexpected thing that many people tend to forget about are all kinds of ICMP unreachables that can occur for a number of reasons. TTL landing on the packets, firewall filters. Why Cisco, for instance, for many years have been recommending that IP interfaces are equipped with ICMP unreachables, new ones, in order not to overload the CPU with processing of unnecessary traffic, without which everything will work just fine. Let's take Cisco routers as an example. You'd be amazed how many queries are made about high load on the CPU. The simplest search in Google will deliver more than 2 million results. I mean, people keep asking, my Cisco router CPU is overloaded. What do I do? What do I do? And there are manuals and instructions for troubleshooting of this. But it affects not only the Cisco, but Juniper, Huawei, Extreme, Brocade. Everybody is affected. So, which traffic goes to our CPU? Here is an example. This is a Cisco router. So, yeah, we see some process traffic. We see that the central router CPU is loaded with normal processes. But in the middle, at the top, you see the number, 16%. What is this 16%? What's this number? We don't know. We don't know. This is a traffic that somehow got onto the CPU. It's some kind of service traffic. Maybe it's TCP/CNs. They are not classified yet. They haven't been converted into BGP or into RSVP. It's some kind of traffic which creates a load for the CPU. What can we do about it? One solution is called control plane policing. We limit the band through which the traffic goes to the CPU of the router. The control plane policing is applied on the interface from ASIC to CPU. It's a very useful thing, easy to understand, but it has its own limitations. Cisco, modern Ciscos. The policy is active. Modern Junipers also do it on the loopback interface, but there is a limitation, like I said. It can apply to internet traffic, or it can apply to internet IPv6 traffic, and the traffic that has not yet been classified, or traffic that comes with other ASA types. It can still hit the router's CPU, and it can create a very high load on it. What can we do with this traffic? The logical thing would be to limit the band for different types of traffic. If we can't get rid of this traffic, we can't get rid of this traffic because the routers still have to respond to pings. Sometimes they have to respond to trace routes. And, of course, it has to respond to BGP or SPF or LDP or RSVP, MPLS. All of the control of the management, all of this should also be led through. But we can limit the band that is allocated for every type of the traffic. For every type of the traffic, we'll set up a policy. We'll set a policy for SMP unreachables. If we know that it's SMP traffic and we'll need to respond or we'll have to receive ICMP, we will also limit the broadband for LDP, RSVP, BGP, AZs, or SPF. Why do we need to set an individual policy for every type of the traffic? If something is wrong in the BGP protocol, we don't want our router to die on our network. Okay, let it die on BGP from outside, but on MPLS, we need to keep it alive. The same applies to internal protocols. HTTP, ISS, or SPF, the protocols, let them work. And if something goes wrong in the protocols, let the router stay available for other protocols, at least management protocols. And that's why we need to set individual policies for every type of traffic. There is also unclassified traffic. A good example of unclassified traffic is ARP. ARP comes with its own ether type. And there is a nuance. We had a couple of cases like this. There's a router, two legs on the uplink. One of them is the main uplink, the other arm, say, backup. BGP, everything as it should be. And then it starts shouting BFD. It starts shouting that on one arm and the other arm as well. You look at the logs, everything's clean, everything's fine. There is no interruption on the network. Nothing seems to be wrong. You go to the router, you ping the neighbor, you wait for an hour, you wait for 2 hours, and it's clean. Everything's fine. Everything as it should be. And then you say, okay, probably I was delirious. But as soon as you calm down, the interface starts shouting again. It turns out that some routers have the so-called default ARP policy. All ARP traffic that goes to the router CPU is limited by some kind of default policy. The clients ask the router, which MAC does this IP has? Which MAC does this IP have? And the clients, there are many clients behind the router, 2,000 clients, 3,000 clients. And the router runs out of ARP records on uplinks. It doesn't ask the MAC address of my uplink every time. It relies on its own ARP cache. And then it turns out that the record is outdated, and if it's outdated, the router tries to send another question, but the ARP answer goes into ARP policy, and the ARP policy rejects it. And we lose connectivity on one of the uplinks, and suddenly everything goes bad. But there is a solution, actually. What you can do is you can break down the interfaces into uplink and client, and every interface will have its own ARP policy. All clients will go into one ARP policy, and all uplinks will go into the other policy. The same sometimes happens with access. If at some internet exchange there is a routing loop, then broadcast traffic is multiplied. There are a lot of ARP traffic suddenly to the exchanges, and this traffic is rejected by the policy. It means that somewhere a record in the ARP cache is outdated, and a strange question arises. Someone comes to you and says, "Hi, we are your neighbors on the internet exchange, and we see that we lose connectivity to you from time to time. But on our side, everything's fine. The sessions are up. Nothing's wrong." And we start investigating, and it turns out to be the fault of the default ARP policy. ARP policy, that's ARP 4, right? But there are other nuances about the protocol which I hate, to tell you the truth, and I think Alexander already knows what I mean. The protocol's name starts with IP and ends with V6. IPv6, it turns out that there are different entities asking about the neighbors. This one asks about the neighbors. The other one, the IPv6 neighbor discovery. And the IPv6 neighbor discovery eventually ends up on the router's CPU. And from the logs, I see that here we received a lot of requests, there we received a lot of requests. Here the router started defending itself. Here the router started defending itself. And to add a normal policy is impossible. At least we couldn't find a way to do it. Most likely we will be able to do it in the next quarter. We'll have to do it just to make sure that our CPU is not overloaded with IPv6 requests. So I ask you to carefully monitor the frequency of your router's CPUs and think about tomorrow. Every time when you are introducing new functionality to your network, like VRP, we change the control plane policy. We implement BFD in the network, we need to change the control plane policy. We deploy a new protocol, we switch from LDP to RSVP, we need to change control plane policy, we need to modify all firewalls. We want to thank the hardware manufacturers because they allow us to use some templates from inside the configuration, like apply path. In Juniper is one of the most powerful things, and Vir6R, big Cisco's allows that to. And it really simplifies the task of building filters. Control plane policy on the 65 without apply path, without an analog to apply path, it's very heavy and it's very challenging. Thank you. Questions? Testing. Andrei Tishkov from MTS. Kirill, a question. All of this is fine. We need to police. We need to set limits. But best practices. How do you monitor that our BFD eats up 20 packets a minute or something? How do you monitor that? I have a default router. It's not set up, and I want to defend that. I deploy COPP, and what do I do next? How do I monitor it? I mean. Over here, one line before last, that's a count. So you can set the count first without the policy, and you can monitor the changes on the count. The count is on the routers are usually SNP or GSP or telemetry based. You can monitor the changes on the counts, and empirically you will decide what you really need. What you need to do. Something to add. Kirill spoke about ARP packets at the internet exchanges. All he said is absolutely correct. We are constantly trying to fight against it. And the important thing is not only to protect yourself, but also you need to make sure that your own network doesn't set the internet exchange up, because there are some vendors that love to send ARP with very high frequency, and we have to work against them. And it's not good. It takes up our resources. In absence of other questions, thank you very much, Kirill. And now we will have a quick break, and we will continue according to the agenda. Please be back here.
Приветствую тех, кто смог вернуться.
I want to welcome everybody who managed to return after the coffee break. I see that not everybody has already joined us, but we can't delay the presentations any further. There are a lot of speakers today, and we need to give them time to brief us on everything that I wanted to talk about here. We are a digital company. You can find our agenda in electronic form on our website. We do not have any printed materials, but we will do our best to also publish all the presentations after they have been done here on our website as soon as they have finished making the presentations. And I want to give the floor now to our first speaker in this session, Dmitry Bilyavsky. He'll talk about blocking. Hello, my name is Dmitry Bilyavsky. I'm here representing Crypto.com. I'm a senior developer of Crypto.com. For many years, I've been patching OpenSSL, and this obviously forces me to stay abreast of the protocol's news. So I take part, more or less active part, in the IETF processes. And today I'll talk about content blocking and various technical aspects of content blocking. So when content blocking in Russia was first introduced, we all lived in the era of HTTP protocol, and there were no technical limitations on blocking anything anywhere. DNS queries were published openly. Domain names were published openly in this domain name in the same open fashion. We communicated the address that we wanted to access. So basically, all of this theoretically allowed us to block effectively and in a very targeted manner all the content for whatever purposes. So what could have potentially gone wrong? It turned out that all the house-made content blocking software was not an easy trick. An online casino blocked the content, and the host name was could not fit into one packet, and this is how they overcame the blocking. And eventually, when the URI was used, and if there are several parameters were used, the order of those parameters could have been changed. And again, you overcome the blocking, or you can change the host name capitalization. So it was quite easy, actually, to evade the blockings. It was as easy to do as it was to set up the content block. And then, starting from 2014, as Alexander Venedyukin has already explained, massive deployment of HTTPS started, and things were suddenly different. We still had unencrypted DNS queries, but in the HTTPS protocol is encrypted, and the host we're trying to connect to and the exact URL are encrypted. So to block a single page on an HTTPS site is technically impossible, but it's possible to block all of the site at once. To block the website all at once, you can use two fields when establishing a connection. One of them is server name indication, when it's a handshake message, and also the server certificate, which is returned by the server. In practice, Well, in fact, collateral damage, it says that. In practice, we had a lot of collateral damage at that time because IP was used to establish blocking. To go to the level of host using the headings required more powerful machines, but since HTTPS propagated and server name indication was now supported by all software, hosters started to deploy several HTTPS websites on one IP, and it worked. And the blockings were now affected many websites. There was a lot of collateral damage, like I said. My own blog was blocked. And when I wondered what was the problem, I was told that my IP address was identified as an IP address hosting an extremist resource. I was very surprised. But there are ways to circumvent the blocking. I don't want to describe them. I think we all know what I mean. In the spring of this year, Telegram was blocked. I wanted to thank Phil Collins for his Usher.club resource when an attempt was made to block Telegram. Up to 18 million IP addresses was blocked at the peak. Some of these IP addresses have been unblocked since then, but 4 million addresses are still blocked from Russia. And among other victims of this collateral damage, a lot of Google.com IP addresses were blocked. Again, on the peak, it was about 60 IP addresses. And given such a massive scale blocking, we had to face the complications that people did not think about. Many websites use JavaScript libraries from blocked sites, and if the site is blocked, actually your own website doesn't work either. So you have to find those libraries fast, transfer them to your hosting, or rewrite all these libraries again on your website, and all of that. Another funny case, quite an exotic case, when the site itself is not blocked, but the DNS queries are within the blocked range. The DNS addresses are within the blocked range. Speaking from personal experience, I know that these things happen. This never negatively affected Telegram, at least on the phone or the smartphone, but the web version, yes, it suffered. But that's not the end of the story. In August this year, TLS 1.3 standards was adopted, and immediately it was deployed on the libraries. It's supported by the browsers, but not very much supported by web servers. So what do we see there? The server certificates are now encrypted. So everywhere where you have a connection using TLS 1.3 protocol with a server, all the and in HTTPS, just like in HTTPS, it's not possible to trace URL. It's not possible to trace the host in the queries. And another thing happened this year. A wide implementation of the DNS. Cloudflare, that was already mentioned today, started offering the DNS at 111 address using an encrypted protocol, among other things. They also came to an agreement with Mozilla, and now an encrypted DNS can be included into Mozilla if you have already activated it. You know that some people complained, like Cisco Umbrella, like when we analyzed DNS traffic in the past, and now we can't. HTTPS follows the 443 port, and you can't block it on a whim. Another document is at a stage close to complete standardization. This is encrypted ASNI standard, which is already supported by large CDNs. They are supported at the stage of development, but when the specification comes about, it will also be implemented without delay. So what follows out of all of this is you will not be able to block what you can get out of the protocol. You can use IP only for blanket blocking, but don't write laws, write code, right? And that's maxim rules. Content blocking has implications for architecture. The system becomes more complex. If it becomes harder to understand, why can't I see that site? What's wrong with it? Maybe it's blocked. Maybe it's not the site that's blocked. Maybe it's DNS that's blocked. Maybe it's something else. The lists of blockings lead to a possibility of new attacks. You take a domain on the list, on the blacklist, and root servers are mentioned as their IP addresses, or bank servers, something that shouldn't be blocked. And most likely, new attacks will be devised. And right now, Roskomnadzor has about 2,000 domains blocked, which are not registered. And anybody can register them and organize any kind of attack. Of course, at the provider level, the architecture also becomes more complex to support the blockings, and also from time to time, rumors fly around that during the next mass-scale blocking, provider equipment failed or will fail, ran out of memory, of storage, whatever. There is also a risk of human error. What I heard from Mesha Club, Roskomnadzor's IP v6 with /32 mask. Maybe there was a typo. Maybe people didn't understand what they were doing. But it doesn't work like that. But does it mean that the internet cannot be blocked? Well, of course it can be blocked. Of course you can do it, but the consequences from my point of view will be horrible, because only IP-based blanket blocking will be available, and then RUNet will be isolated in the narrow sense of the word, and libraries will not be, you will not be able to use them, or outdated libraries, those versions will be only available, and there will be difficulties in accessing resources, even using search engines. We all Google for a solution of our technical issues from time to time. So if we can't Google, then very soon degradation will ensue, and I hope that sooner or later a reasonable political decision will be identified, and the internet will not be blocked. Thank you. I never doubted it. Alexander Xavnian from the Internet Defense Society. I want to thank the speaker and the organizers of this forum for the first time in Moscow at such a major event. The topic of not very good consequences of the content blockings was presented to such a wide audience. A question to Dmitry: what would be your recommendation to the Russian parliament? Milonov and Yarova, the parliamentarians, are asking you, so what do we do next? What would be your recommendation to them? Well, I wouldn't be able to say publicly what I would love to tell these people. Okay, if not publicly? Okay, got it. Yes, thank you very much for the presentation. Moving on. Apart from blockings, very often we talk about, here at these events, we talk a lot about the network and monitoring of the network. Today we have Maxim Raevsky from Ivy, who has something to tell us about on the subject. Very well. I will try to tell you quickly about what we do at our online movie theater in terms of network monitoring. We are a content delivery network, basically, and we use Unicast, as you are well aware. Unicast has certain features that we need to understand so that we can understand how monitoring can be done. The concept of Unicast means that we have very little influence over which node and which hash is used to service this or that customer or a network. All this management, all these decisions are based on BGP protocol settings, which are managed by a network operator, not just one, but the whole chain of those operators between us and the end user. We have very few tools that we can employ to make an impact on this black box delivering packets between us and the end user. We can do prepend, we can build a community, we can block an announcement, but generally speaking, for us, that chain is a black box. Sometimes it's blacker, sometimes it's less black, but generally speaking, it is a black box, and we would love to know where our customers are serviced. And when customers call our support line and they tell us that I'm not getting your 4K in 4K, it's not 4K, maybe it's not K, it's G. Actually, we need to do something about it. We need to help the customer. Although we can't use the tools of geographical balancing and we can't use DNS techniques and other applied HTTP techniques that are available to our colleagues. We'd love to be able to do that because we suffer the consequences if our customers are not happy. We have our own KPIs. There are two main indicators that we trace. The first one is the time that the video is started between the time that the user said, I want to see that movie, and press the button, and till the time that the movie started displaying, and also the number of interrupted broadcasts when the movie was set on pause, on hold, not by the user, but for technical reasons. Buffering is what we call it. There is no movie, there is no sound. So both the starting time and it should reach zero, and the number of interrupted or buffered viewings should also be as close to zero as possible. This is our CDN network. It right now has 33 nodes. Well, actually, this number changes all the time, and I stopped counting really after 20 nodes. Our current counter that we installed there says we have 33 nodes, and I believe it. But why such a network? The country is big. RTT from Moscow to the farther reaches of the country can be 20 or 30 milliseconds, and the longer RTT, the lower the TCP throughput capacity. So our objective was to bring the heavy content, the traffic, to the user as close as possible, so that RTT is lowest and the probability of things going wrong and us losing the packets and TCP connections being disrupted. We want to reduce those risks to the maximum. But what if something goes wrong? How do we find out about it? And it would be best if we found out about it not through an avalanche of phone calls or emails or social media posts. We decided that in order to be able to monitor those predicaments, we have to follow 4 key indicators. They are listed now on the slides. Connectivity, the connectivity between our unicast address and the user, whether it exists or not, a specific user, a specific network. From which node is it being serviced, so that we would know where to go to, what node to fix in a bad scenario. And RTT, what's the RTT to this node? We need to know, because in Moscow we have the normal vanilla flavor unicast addressing. So we thought about it for a while and devised a technical solution that's based on unicast peculiarities. We came up with a solution how to collect the information on those indicators. Well, first of all, we use check IPs. It's a name that we use for hosts. We know where they are in a specific region, in a specific network, and we know that they have a high uptime. And we identify that uptime, this host is either available or it's not available, and over what time. Not to kill it off with a flood of unnecessary packets, we decided that our checks will be run every hour. We have a list of about 300 hosts. I think we send ICMP echo requests from all our nodes to those hosts, and then we analyze the responses. If an echo reply is returned to a specific node of our CDN, then we will know for certain that this host, that this network is serviced from that particular node. And then we can measure the RTT time, obviously, and record it. And after that, there are different possibilities. If the echo reply is not returned to neither node, then it's either a black hole because of our unicast, or this host is off, it's down. In order to differentiate between these two scenarios, we would ping those check hosts from Moscow with regular unicast addressing, and if the host is switched off, then Moscow will not get any reply either. But if the reply is returned to Moscow, but it's not returned to the region, it means that it's a black hole, most likely. Another scenario is also possible when more than one node in our CDN receives an echo reply from the same check host, and with a 90% probability, it tells us that in this operator's network, multipath is enabled and it balances between different cities. And in a couple of cases, you may laugh, I was told that they're not using BGP, they are using static, and I was really hysterical. And in the remaining 10% of cases, that means our own transit processes. Pinning a lot of hosts from many nodes takes a considerable time, and during that time, routing in the internet could have been modified without our involvement into the process. And sometimes it happens that during maintenance we would disable a particular node, and that node, say one node has already identified a customer sticking to it, but the load was transferred to another node, and that node also records the same customer. It's a transient case, and within an hour or during the next cycle, the situation will be resolved. But of course, we would still collect this information in our WebEx, and we'll see beautiful curves and alarms will be sent out. And of course, we have to monitor this information. The check hosts that we select, again, they could be down or they do not respond to SAMP. We have to monitor it. We have to find new ones in the same region so that our list stays relevant and up to date. One of the most difficult challenges during monitoring is maintaining the list of check hosts relevant, keeping it relevant. The main sources are listed on the slide. Good people, good operators have a looking glass, especially the best ones, the really best ones. You'll be able to see different geographies in the network. Traceroute is still valid. In the era of MPLS, it's not as elegant as it used to be in the past, but it still allows you to collect information. Common ping, because we can assess latency, we'll be able to triangulate the location of this or that host. If we ping the check IP from the looking glass of a connected operator, who we know where that operator is located, I will know that then if this host is in the same region or in a different one. So even with a common ping, you can collect a lot of useful information. RIPE-DB, some people try to maintain the records up to date, and we want to thank those people very much. We are subscribed to the IP address database, and it shows us the city and in most cases the operator, so we use this for cross-checks. Reverse DNS records helps us identify a host all the way to a zip code often, and sometimes we just get lucky. So the last item there is magic. Those are the main scenarios that we can that we are informed about by alarms. In some cases, say a Vladivostok operator starts getting service from Moscow, and it's not good for anybody. And when we see such an event, we will be able to react. Either we can write to this operator, or we know that sometimes it's just maintenance, and this is just some kind of, a regular technical issue. But sometimes it's wrong settings in the BGP. And I have already said, I think that I'm surprised that the internet still works. Okay, never mind. We are also getting alarms that say a host is unavailable, and for us it's an indicator that maybe we should change the check IP address for this operator or for this region. And of course, we get an alarm that in a particular operator's network, multipath potentially is enabled. If RTT grows suddenly, then again an alarm is generated. Maybe it's an accident, maybe it's overloading, maybe it's an error in measurement, but it's useful to know these things. And of course, the highest priority alarm is the one about a black hole. And we have to take drastic measures and be very active in that scenario so that the users are happy. And now the pictures. These are the results of our monitoring for a week. for one of the large providers in Siberia. Every curve shows a different city in Siberia, and this is an RTT curve to Moscow, RTT to Moscow. You can see here some RTT surges, especially during the weekend. The weekend is shown in the middle of this graph. So yeah, things happen. Same operator, same cities, but from the local CDN node, from Novosibirsk to be more specific. You can see here RTT is more flat, and periodicity is less pronounced. If you look at this fence, you can tell me, Rayevsky, there's something wrong with your measurements. Well, yeah, you could say that, but let's take another look. This is a different operator. This is, again, Siberia. Some of the cities on this graph are the same as the cities from the previous slide. Others are not, on the other hand. But it gives you an idea. You can see that this provider's RTT to Moscow is very stable. Those two elevations here, maybe they can be attributed to an accident or some maintenance. I mean, things can happen during a week, and RTT growth is not catastrophic. Same operator from local nodes, several nodes in Siberia, not only in Novosibirsk. We can see here RTT here is stuck. It's glued. It doesn't change almost. I will not show you the previous slides again, but you look at the scale also. You'll see that we are talking about a different level of variability. And since this is an Msk-Ix peering forum, the first operator is not a member of Msk-Ix community, and the second one is. These are the nodes. Second provider. Most of its Siberian cities are serviced from Novosibirsk, one of them from Irkutsk. I think it's Irkutsk. Another alarm. This is a multipath alarm. So that's what we see, more or less. This is a provider in those cities. We suspect multipath. They do not reply to my letters, but okay, they have themselves to blame. If we see the same alarm for the same operator several times, it tells us that for every level of our cache, which is shown here as Anycast 2, we have separate monitoring. Here is another beautiful picture, beautiful visualization that was prepared by a guy who unfortunately no longer works with us, but as his former boss, I still remember him fondly. And Vasya, if you are connected to the online broadcasting, I wanted to thank you for this beautiful visualization, and I'm done. Questions? Maxim, hello. Thank you very much for the presentation. You are also the adept of the monitoring church as your compatriot. I wanted to give you a piece of advice, if you would take it. Ping. The operators know how to. I understand what you're going to say. No, they deprioritize ICMP all the way to non-replying at all because they don't want to transfer the stuff. Well, okay, as to your last comment, very often customer and end user will nag at the operator for ages, forever, before he gets there. But I suggest that you measure TCP in time and reply. I know exactly what you mean, and unfortunately, if we go all the way up to TCP, this monitoring model will break down. No, it will not. Another thing, you are saying that you use two important KPIs, and the first one is the time to play in the video. I opened the laptop, I go to EV website, and I started a movie with an advertisement. Tell me right now, how many requests did I have to make for the video to start? How many requests did I have to make? What do you mean, HTTP? What's your best guess? No, I don't want to guess. I know a lot. The answer will be a lot. Excellent. 200. Little. That's little. 200. What's your best bet? YouTube. YouTube. No, I don't know. 60. It's 60. For YouTube, it's 60. Do you understand it? So my question is, if your KPI is time to start the video, it's time to start playback, well, it depends very much on how you code the front. Connectivity is important, yes, but to measure it with a ping, trust me, it's wrong. Try Msk-Ix, because the browser, you say, oh, TCP, that's too high up, but the browser works well with TCP. HTTP, HTTPS, that's TCP stack. And your video, it doesn't play on the GMP protocol. Thank you. Can I respond to that? Yes, thanks, by the way, for your comments. I agree with the technological argumentation that you've just presented. I mean, I will not criticize what you said from the technology point of view. In terms of high-level pings, guess, well, yeah, probably. But you see, we did it for ourselves, and for ourselves, well, like we agreed that it suits us, okay? And as to the time to start, yeah, we have people, especially trained, who take care of that. I'm surprised that 200 is too little. That means they did a good job, because in the past it was worse than 200. It was much more. But I work on the network side, and I explain what I can manage, what I can control, what I can measure. Thank you. I too have a quick question. Maxim. What I saw is that some companies who are like you, they, for the end user, they will let you see which node the user sits on. Do you have a URL, like a page, to say that I'm on node such and such, and then I'll send it to the EV technical support? No, my answer to your question, well, yeah, but no. We have a page which is called ipev.ru, and it collects diagnostic information, and it identifies the speed at tier 7, and HTTP request is sent truly to 3 levels of cache. The nearest, the regional, big regional, and central, which is in Moscow. So those numbers will give us information on connectivity, and we'll know how it works for the user. This page collects the information. We record it. We know from which node the user downloaded this checked data. The user's data from which node the user is serviced is not shown, but there is a hack. You can go to URL on which our CDN sits, and without identifying the name of the file, just go to the home page. You will see an error, not found, and then the code of the server. So it's a hack that we use from time to time. Okay. Thank you. And if there are no further questions right now, then thank you very much. I just wanted to say that our presentations will be made available online almost in real time. So right now you can go to our website and you'll be able to see the presentations that have already been delivered today. You can look at the slides. And before I give the floor to the next speaker, and the next speaker will be speaking English, I just want to make an announcement. If you want this presentation translated into Russian, at the back of the room we have headsets. We can give you time to go and pick up a headset. All our presentations are also broadcasted in 2 languages, in Russian and in English. You can listen to them in either language. Our next speaker is, and I have to say, it's a new thing that came about in last years, and many operators, many players are already using this novelty. It's a peering DB, peering database. We invited here a special speaker who will discuss the opportunities presented by the peering database. Please welcome Rebecca Stanich. And questions, I think you'll be able to ask questions either in Russian or in English, because Rebecca will also be able to hear the questions translated into English.
So I can understand. So hi everyone, I'm Rebecca Stanich. I'm part of the outreach committee for PeeringDB and also work for Retin, who you may know a little bit better than PeeringDB. So this is the PeeringDB update, but it's also an introduction because I'm fully aware that PeeringDB is not used in Russia quite as much as we use it in the rest of Europe. So what is PeeringDB? Basically, it's a non-profit member organization looked after only by volunteers, and it's to enable the distribution of information about internet exchanges, facilities, and network operators. Basically, how do you find people, how do you find peers, and who should you be speaking to? All of this information is found on PeeringDB. If you're not registered at PeeringDB, it's very simple. The website address is on there and will be made available, so it's peeringdb.com/register. In terms of basic verification, we will check your WHOIS record, so please keep it updated. And when you set up your account, you need to email from your company email address or at least an email address related to your ASN. Otherwise, it's going to slow it down so much. So why should you be using it? For a start, it's a lot easier to find people and the correct person. It's not always obvious who looks after peering within a facility or within a company. You can update all of the record, so you can also use it to automatically generate all of your peering sessions. So, for example, if the maximum prefix changes, you can put this information into PeeringDB, and it will do all the config. But more importantly, a lot of major networks will not peer with you if you don't have an updated record. To give you an idea of quite how strict they are, every single one of the major content providers request within their PeeringDB file that you have an updated system. Cloudflare take it even further. So they provision all of their configuration automatically via PeeringDB. So if you do not have a PeeringDB record and you want to peer with any of these networks, it's not going to move forward. They will simply ignore you. Okay, so this is a bit of housekeeping. A year or so ago, the PeeringDB board sat down and sort of said, okay, what should we be concentrating on in the future? What do we need to do to ensure that PeeringDB is a tool that can be used by the members, by the people using it? So we came up with a list of points that we feel are important. There's really making sure that it's a reliable source of information, that the database is not full of information that as I said, it's not reliable. So this is one of our primary targets, and we work also with EuroIX and the IXs directly to ensure that that's in. In terms of your own PeeringDB record, you are responsible for the information held there. So we are relying on you to make sure that that is accurate information. We're also trying to educate the community a little bit more and evangelize the use of PeeringDB. This is why we have an outreach committee, and this is why I'm here. Also to speak to people that are using it. What do you need? What don't you think works very well? Furthermore, we wanted to really push forward on the operational level. So improving the infrastructure that it runs on, the SLAs, making sure that we had a third-party security audit that we now run every single year. So those are some of the housekeeping points. In terms of the committees, we have 4 committees. There's the admin committee. They look after any of your tickets that are raised. Then we have the operations committee, so looking after the infrastructure. Outreach, I've already covered that. There's about 4 or 5 of us that go along to conferences, do these presentations, speak to people, check that everything is how you need it. And perhaps most importantly, the product committee. So the product committee are the people that you want to speak to if you find a bug or you need a feature adding, or if you want to talk about translation of PeeringDB, which I will get to. So the best way to contact them, product.com@list.peeringdb. And we also use GitHub, which I will get to in a little bit. So that's the housekeeping done. What have we done in the past year? There's been an awful lot of updates. We've got through quite a bit this year. So we have new hosting infrastructure. We've moved forward with OAuth authentication via PeeringDB. That's because so often it's the same people at all of these peering conferences. So we're enabling that we can use OAuth authentication so that it makes it easier when you're at the peering conferences to find people. We've gone ahead with all the security updates to address all the issues found. And as I said, some of the more interesting thing is the internationalization feature. I'm going to get to this in a bit because the one for Russian language has progressed, and there's been a couple of updates in the last couple of days. I've already mentioned it, but features, bugs, fixes, many of those have been made. And if you're interested in what has been sort of progressed already, as I said, if you go to GitHub, this is where you can list anything that you think should be added, or you found a problem. Please put it on there. I will show you the address later. But you can also see what's the progress. Is the product committee doing anything about it? Do they need to do anything about it? Okay, so this is one of our major announcements. This only happened in the last month. We've been working pretty hard to make PeeringDB open source software. We had to do a full security audit, first of all, and now we have launched. So why is this important? For a start, it's beneficial to the entire peering community. So we now allow the volunteers to contribute directly. It also means that when we go out and ask for bids on anything product related, it makes it an awful lot easier. And we will be working on accepting contributions and how to do that. Here's the GitHub site that I keep talking about. So if you go along to github.com/peeringdb, as I said, you can see all of the issues that people have raised that they feel we should be working on, and you can track the progress there. Please do use it. If there's anything that is specific for your market that you need, please do let us know. I cannot say this. Somebody can translate it into Russian for me. So basically, PeeringDB, it's a great tool, but it's not a great tool if it's not in your own language. And we've noticed in certain markets, a lot of Asian markets and also in Russia, that less people are using PeeringDB. And that is because it's not in Russian. So we've gone out to specific markets and asked people to help us with this. In terms of how you would use it, you simply log into your profile, you go to the language, and it will switch everything to it. I normally ask for people to get in touch if they're interested in doing translations. As I said, as far as the Russian translation, this has now progressed to the point that it's just been loaded onto the beta side. So we are checking if there's any issues with that, but soon PeeringDB will be fully available in Russian, at which point we expect everyone to have a PeeringDB record and be fully using it. If there are people who would like to volunteer and translate PeeringDB into other languages, then please do either email the product committee, or if you want to have a chat with myself, I'm around for the rest of the day. But how do you go about doing that? So everything, again, goes through GitHub. You go to GitHub, you generate the local files, then you select the language that you need to translate. Once you finish completing the files and all of the edits, you get a pull request from GitHub, and then you can upload those. So as I said, the Russian language is now at the beta testing site. So that's where we're up to there. Please, if there's any volunteers that would like to work on this, do reach out to us. So far, we've not got that far. We've got English and we've got Portuguese. We've got a number under development, but the more people we can get working on this and the more people using PeeringDB, the easier it will be to interconnect. Okay, then I have to do my sales pitch. So obviously, as I mentioned, we are a not-for-profit organization, fully run by volunteers. So if anyone would like to be a sponsor and help us keep running PeeringDB, here are the various packages. I won't spend that long on it. Of course, thank any of the sponsors that are in the room. Thank you very much for helping. And here's a list of information resources. So obviously this is going to be on the website for the peering forum today. But I would like to draw your attention to a couple of those that are really helpful. So all documents, presentations, guides, how to use PeeringDB, step-by-step guides can be found on docs.peeringdb.com. It is really helpful, even if you just need basic information and are wondering why you should be using it. And there's the GitHub address. So bugs, feature requests, checking what's being progressed, please go to that. Okay. And that's it. Any questions?
Вопросы?
Are there any questions? Well, maybe I have a question. I have a question to the audience, actually. How many of you are already using PeeringDB? Can you raise your hands? Who has access to PeeringDB? Oh, almost everybody. All of the room. Then I just wanted to say that Msk-Ix organized translation into Russian. But because we were working under certain time constraints, and well, right now this translation is already available in the beta version, and you can go there and test it. But the data in this beta version is old, so you can test the language, but you should not use the data in the beta version. And I have a question to Rebecca. So we at Msk-Ix, we have now this feature which allows us to download the data from the Msk-Ix, from the Internet Exchange, about our users. And we upload this data via JSON to PeeringDB. But there is this strange thing for the user, for a member of a community, to so that on his page, the information would be included that he is a member of Msk-Ix. He has to enter PeeringDB, and he has to tick a box authorizing us to display the peering parameters for this user. Majority of operators, by default, are not doing this. No one is entering the system, and the box is not ticked. It's disabled by default. So a question to you, do you intend to change the default settings? Are you thinking about maybe sending reminders to the users to tick this box so that they can showcase their presence?
It's a good question. As I said, yeah, we're now working with ROA so we can pull that information across. We do have to ask the members that they're okay with that information being shown. It's something I can take back and see if, yeah, by default, so they have to untick the box if they don't want the information sharing. I mean, I think also it's a question to ask your members if they would have a problem with it as well, but if the majority of the members of Msk-Ix are happy with it, then I think even if it's just something we do for this exchange, then I think it's something we can achieve.
Да, согласен, что по умолчанию здесь надо рассмотреть возможность изменений.
Yeah, I agree. That's a good idea. Thank you very much. Yep, thanks.
Ну и первая часть.
And that means that we have completed the first morning session. We will break now for lunch, and the peering forum will start here at 2 o'clock. Please be back here for the plenary session. Thank you.
Дорогие друзья, добрый день.
Dear friends, very good afternoon. Let's get started. We have these special effects today. Hopefully they will not distract us from the program. Our forum has a very interesting layout. We have the opening ceremony in the middle of the day. So since this is our very strange tradition, so I want to start with something that is usually done at the end. I want to thank all participants and everyone who is going to take part in the panel discussions and everyone who was involved in preparing this forum for the organization, for the presentations, for the open experience exchange. So as the head of the program committee, my task is now completed, and at this point I pass the floor to Irina Voronina, General Director of Msk-Ix. Very well, Kostya. I take the floor from you. Good afternoon, dear colleagues. Welcome to the 14th Msk-Ix Peering Forum. I want to thank all our sponsors and partners who provided financial assistance to the organization of the event. This year's general partner is Rostelecom and their data center. It's a national network of data centers. Our very special partner is Module, and we have several standing partners and sponsors, Msk-Ix, the Technical Center of the Internet, and Nginx, Data, Technogorod Data Center, Transneft Telecom, Mastertel, Huawei, Curator Labs, IT-Grad, and VAS Experts. Thank you very, very much. Very well. It's been a year since we last saw each other. The world has changed. Telecom has changed. Msk-Ix is also changing together with everyone. What have we seen already in this year's market? The trend of the last years is the increase in the internet usage. Today everybody uses internet. Everybody knows what internet is. We use domestic appliances that are connected to the internet. We make financial transactions online. And the government, too, is using internet. The government tries to protect the internet, and at the same time it starts offering more and more e-government services. The IT landscape has changed. All IT operators, all telecom companies today are providing comprehensive services and are very set on the whole digitalization track. What does that mean for our market? It means that there will be more and more content and traffic and transactions online. It means that there will be more threats too, and usually security, online security, becomes the leader in all online transformations. Traffic localization is also very important. Several years ago, we raised the flag of peering under the motto of cutting costs and improving connectivity and improving availability of resources on our network. But now we must add a bit of common sense to this motto. It will look very strange if we start controlling our electric kettle via several national borders. So traffic localization remains relevant, but as we have already agreed, modern day dynamics is very dynamic, is very fast, and we must move fast and we must move with the times. What does Msk-Ix do about all of this? Where is our place in today's market? Well, we continue operating in the professional services market, and the portfolio of products that we offer targets the professional users, the professional market. We believe our main priority is helping businesses in setting up their operations. We help network organizations develop their networks and their services at less cost and faster. And for this, we build and we maintain a highly available network. We are ready to connect fast. We are ready to connect, to expand ports fast. We are ready to provide enough capacity for the traffic to the extent and where the traffic requires that capacity. We invest our experience and our financial resources into the reliability of our network. There is a lot of backup and redundancy, and we apply other solutions to increase the reliability of the network. And of course, we focus very much on security, although security covers all aspects of our activity. Our main emphasis is on the DNS security and security of high-level domains. Among other things, we are also striving to make Msk-Ix network to the maximum number of endpoints wherever our network is. So from this perspective, our priority is developing the partnerships and expanding the geography of our coverage. Colleagues, if you haven't joined us yet, it's high time you did it. Do become our partners, and thank you very much for your attention at this point. I will return the microphone to my colleagues. Thank you. Okay, we all know what lies ahead, but we decided that we will break our routine a little bit. This time we will organize our presentations in 3 rounds. And our first round will be on partnerships and Msk-Ix initiatives. The presentation will be delivered by Evgeny Morozov, the commercial director of Msk-Ix. Hello, colleagues. Welcome. Good to see you. I couldn't agree more with our general director. Our mission is to help others and to develop various services in the internet. And of course, we can't help others if we do not develop ourselves. And where are we moving and what can we offer today? I'll try to be brief and not to engage too much of your time. Our product portfolio today is this one. You know that Ix several years ago stopped being a purely peering platform. Today we offer a suite of various value-added services like hardware collocation and partner services, access, and Ethernet. And all of these products are available in the one-stop shop mode, and many of our users and partners and customers subscribe to several products, not just one. We do our best to be user-friendly, and most of our services, again, can be connected via one port. So it's a one-port shop, really. You can get the public peering areas mix. That's when you are connecting from one city to route servers located in other cities. And on the same port, you can connect to private peering, which is a redundant L2 VPN channel. Most of the customers will be able to connect their data centers in several cities. They will be able to connect their equipment in those data centers. Media logistics is also available on the same port. You do not need to do extra crossings, and telecom operators, when they're getting the signal, or the broadcasters, in order to submit their signal to be transported across Russia, they all use the same port to which other services are connected. And we also develop services together with our partners. Today at our platform, you can connect to IP transit providers. On our platform, you can get access to cloud services. There is also a possibility of connecting to providers who offer the services of DDoS protection. And this link can be used to get cleansed traffic. Again, we call upon everybody, and we are ready and we are open to new partnerships. You see, the slide is not very busy. It means that there is still space for the slides to name the services that we'll build together with you next year. If you think that your service might be interesting to other Msk-Ix users and it requires a direct communication, direct connection between the supplier and the user, then Msk-Ix is exactly what you want. In support of the idea that we should be user-friendly and the customers should feel comfortable in our environment, we improved our users' accounts. You can monitor your ports, you can get alarms and messages that you can order additional media signals if you use media logistics services. You can order all jobs to enable or disable the hardware that's placed your equipment that's placed in our data center. A couple of words about our data center. You must have heard about our Plus project. When we started this project 18 months ago, we M9 Plus. We thought it would be a success not only because of its excellent location, but rather because of its state-of-the-art infrastructure. I have to say that in the last 18 months, we've been observing a trend when more and more tenants are coming to this data center, and there is a good, strong dynamics for location of the hardware. So if you are thinking that you need to solve your hardware placement problem next year, I think you should act faster and call us before this year is through. Media Logistics was another success story in 2018, and the director of Media Logistics projects, Grigory Kozin, is best placed to discuss this project. Good afternoon, colleagues. I have a feeling that it was only yesterday when at the Forum we presented our new media logistics project, but that was already 2 Forums ago. And today I have to say that the expectations that we all had 2 years ago when we were discussing the future of this project and we worried whether it would fly or not. Well, first of all, it flies, but not just that. Media Logistics is not only flying, it has already reached the leading positions in the market of media content distribution. Judge for yourselves, 57%, more than half of TV channels that broadcast in Russia are now available in Media Logistics. There are already cases when the operator, by connecting to Media Logistics, gets all TV channels that they need, and for them, Media Logistics is the only source of the TV signal. Sorry. But our progress is even more pronounced in distribution of 4K channels. Media Logistics today distributes 90%, so basically all 4K TV channels that broadcast in Russia are now available on the Media Logistics platform. Recently, we began to develop our own exclusive package of TV channels. Exclusive means they are the channels that you can get only through Media Logistics and nowhere else. For instance, we have a St. Petersburg version of RBK channel. You can get it only from us, only from our platform. So, St. Petersburg operators, welcome to our club. On the whole, the range of TV channels or media logistics has grown this year. As Vladimir has said, there were many achievements this year. There was a good uptake owing to contracts with international majors, Discovery, Fox, Viasat. We contracted with them that we'll be delivering the TV channel to the Russian operators. But of course, the bigger part of our assortment is Russian channels. And this year, we helped many small operators who found it difficult to connect to RTRS network, to get this connection through us and to get the mandatory channels in the multiplexing packages RTRS 1 and 2. The most innovative package of channels that we offer is OTT multiplex. They are the same standard, like statutory channels that you are getting from RTRS 1 and 2, TNT, Match, Must-TV, and others. But they are different versions of the same statutory channels. This is a package that's designed specifically for online broadcasting. This year, we implemented a rather ambitious plan to organize connectivity to media logistics at the Msk-Ix nodes in all macro-regional centers in Russia. The most remote Msk-Ix nodes from which you can connect to media logistics are located in Khabarovsk and Vladivostok in the far east of Russia. The node in Khabarovsk is so new that our mappers didn't have time to map it on our map. But in any case, even in Khabarovsk today, you can get connected to media logistics services. Apart from this eastern orientation, media logistics is also being promoted heavily to the west. We deliver to the networks of foreign operators the Russian content and Russian TV channels. We have already had projects in Paris, Amsterdam, Frankfurt. My favorite project is on Cyprus. We organized points of presence in Nicosia and Larnaca. It's my favorite project because it's always warm there and there is always high demand for Russian TV channels. There is a good Russian community, or rather Russian-speaking community in Cyprus. If you remember, a year ago at the Forum, I said that we were already delivering the TV channel to 8 out of 10 major Russian operators, and we are only missing TTK and Tricolor to make our collection complete. And I committed a year ago to finish this collection, to have the collection of all our operators full. So I am happy to report to you now that the elite of the Russian operators, the top 10 Russian operators today, are receiving channels and media logistics. That's the big four. And all 3 satellite operators and the largest OTT services. However, a note on the side. I don't want you to think that media logistics is like a Rolls-Royce that's only accessible to the richest, to the elite. No, I'd say media logistics is like a Toyota. It's reliable and affordable to the majority of users. So that's why the biggest box on the slide is taken up by small regional operators. And I want to apologize to those brands who did not make it into the slide just because we didn't have space to feed them all. This year, together, or rather, through the services of our technical service, we carried out another bold project. Media Logistics is now much more transparent and open. And through your personal account, all our customers now can monitor TV channels. All operators who are getting the signal from us, they can access their personal account on our website, and they can get detailed data and diagrams of the quality of every particular and individual TV channel on the Media Logistics platform. Managing services and automating the processes via the personal account probably is not the biggest highlight of the year. What is truly important is the professionalism of Msk-Ix employees that enables us now to connect so fast that whenever there is a new TV channel who comes to us, within one working day, we'll be able to feed it to operators all the way to Vladivostok. And the best illustration for this, I guess the best case to prove it is when Russia hosted the World Cup, Soccer World Cup, and the first channel of Russia fed us 4K signal. They did it in the morning on the 4th of July, and in the evening, the happy viewers and subscribers to cable networks across the country, including the Far East, with a cup of tea in their hands, were enjoying the opening ceremony of the football soccer cup, FIFA Soccer Cup, with the excellent Ultra HD quality. Now, as to the plans of the future, we have even more ambitious targets for next year. We plan to organize broadcasting of TV channels directly from our platform outside, from out of Media Logistics, and in this case, it will not be us getting the TV channel getting the TV signal from the channel, but rather the channel will get a turnkey service from us, and they will be able to organize their own broadcasting right out of Media Logistics. I'll disclose a secret. There are actually a couple of channels that are already broadcasting like this. We do it ourselves, and also some of the big operators are already getting those channels, and we see that the quality is quite satisfactory. But for us now, this is a pilot project, and next year we plan to do it on a massive scale. We also have plans to expand the geography of providing the services. Our vector is set on the CIS in Armenia and Kazakhstan. The projects are about to start. We are about to launch there, and in 2019, we will also have a partner project, which will be a milestone for us, really. What I mean to say is, for 2 years, we were flooded with the offerings of potential partners, both in Russia and abroad, to start offering services through partners, but we rejected all these propositions. We spent 2 years to build our own distribution network, and now we can connect operators, TV operators and partners directly in every macro region in Russia. So now it will be organic, it would be natural to move to the next stage, the partner connections, and it means that now not only in the big cities and in remote areas of Russia, anybody will be able to connect to Media Logistics services through partners. This partnership initiative for Media Logistics is only starting, but in the Internet exchange, the partnerships have been successfully developing for years. That's why I want to ask Evgeny to take the microphone over from me, because I think that Evgeny has some interesting information about our partnership initiative. Well, colleagues, I think you understand that behind every success story of Msk-Ix is its infrastructure, is its network, and its community. The partner network. So all these success stories, the media logistics and other services that I have already listed today, would not have been possible without our partners. Because of them, our services are available today in Russia and abroad. Many of our partners are also our resellers, and with many of them, we managed to build win-win relations when they are both resellers and partners in providing the infrastructure. And with them, Msk-Ix is gradually becoming an integrator. I wouldn't shy away from using this word, and this is a trend. And many companies today acquire new services, they expand their portfolios, and they naturally become integrators. And that's the track on which we are moving, and we are open to partnerships. A partner program is something simple. It's a standardized set of documents, and everyone who knows a telecom operator who wants to become our partner but for some reason cannot connect to Msk-Ix, he needs the last mile that you have it. That is your chance, basically. We would love to see more partners. And it is already an established tradition that during this forum we name the best partners, and we congratulate those partners who demonstrated the highest performance in 2018. Please welcome Denis Shipitsyn from Millicom, Director for Operator Relations. Thank you very much, Millicom. And colleagues, take a look at those souvenirs. I think that Denis will be welcomed. I mean, his colleagues will be very happy to see Denis back in the office. If you want to get a box like this to make your colleagues happy, do become our partner. Please also welcome Marina Americhkina. She is Deputy Commercial Director. And she's probably the best salesperson from RETN herself. Let's take a picture. Alexei, you need to help here. Please also welcome Yuri Bubolev, Director for Operator Relations from the Siberian branch of Megaphone. Megaphone, thank you so much. It's always a pleasure. And colleagues, we're not done yet. We have more to tell you. On the subject of partnerships, Grigory is planning to start a partner program in 2019 in media logistics and Msk-Ix. We have had the partner program for years, but recently an important event took place. Now DECIX is Msk-Ix's partner. So two major IXs announced a partnership. I think you read about it in the news. Let me explain what that means to you as Msk-Ix members. the same port. Remember, we talked about a port that's very user-friendly via a separate VLAN. You can get access to all DECX services, including last mile to Frankfurt with 4 nines SLA. This is a mutual partnership. It means that Msk-Ix services, all of them are available now in Frankfurt. And all DECX clients now have access to Msk-Ix services. And now in the room, we should have Maxim Poznyakov. Maxim, yes, that's Maxim. He is the DECX representative. So if you have questions about how they are structured and what services they offer, Maxim's your man. Please also welcome Roman Zelinsky. He is responsible for this project on the side of Msk-Ix. They are people from this project. Any questions you might have, please find them during the day or later. You can talk all details about all of the details to them. That's it from me. Thank you very much for listening so attentively. Do become our partners and members. Okay, colleagues, as you can see, Ix is not only transfer the traffic, but they are also developing products and service platforms, and they build relations. And today, for you to get a better idea of what our partners are doing in this respect, we invited for you here the representatives of 2 European internet exchanges, and we'll start with DECX. Please welcome Christoph Dietzel, who will speak about remote peering and other research projects of DECX. Christoph, the floor is yours.
Welcome from my side. Unfortunately, I need to speak English because I'm not able to speak Russian. Sorry about that. So I'm the head of products and research at DECX, meaning I'm involved in product management and the global network design of DECX and also all R&D activities. Today, I'd just give you a brief intro of what DECX actually is. So I brought some DECX facts, then I just have 2 slides on the cooperation. We are very proud of to join forces with Msk-Ix. And after that, I just highlight 2 research projects we had at DECX together with researchers from other universities. So first of all, DECX is a quite old exchange, so founded in Frankfurt in '95 with just 3 ASs. And the reason why it was Frankfurt is because Frankfurt is just like in the center of Germany. So sort of a coincidence, a lucky coincidence for us. So it's by now the world's largest IXP if we just measure the peak traffic and also the number of ASs. And we serve and connect over 1,000 networks globally. We have over 14 exchanges, mostly in Europe, some in the US and in the Middle East, and we have a joint venture in India as well. So globally, we have a total connected capacity of about or a bit more than 40 terabits per second. And in Frankfurt alone, we are available in 23 data centers. So the cooperation. So I think there's not much to add what the speakers before said. And you all saw Max, so please approach him if you have any deeper questions. And this agreement actually was signed or the memorandum of understanding was signed at the Peering Forum in Athens not too long ago. And we also prepare a website which should make it easy for you to get the information you actually need if you want to connect through DECX to Msk-Ix or the other way around, as introduced before. So we believe that, this is a very good first step and a good partnership to really connect the 2 data hubs, which is Moscow on the one hand and Frankfurt on the other side. And it's as it was said before, it's a very convenient way to do that, right? So without any extra effort, and the IXP partner maintains the contractual relationship with the end customer, which is also very easy and straightforward. So I guess you know the Russian or the extensive network across Russia from Msk-Ix, and now we have a small picture of the outreach of actually the DKIX network. That's two worlds which we want to combine and to start off with Moscow and Frankfurt. And on this slide you can also see that there's a huge number of sites in Moscow, but you probably all know that better than I do. So this is probably a pitch of the technical setup. So what we just do is we have two times two redundant connections between Moscow and Frankfurt, connecting our peering platforms through VLANs for you. So what this is basically brings me to the topic I actually wanted to talk about, and it's remote peering. So when remote peering became more and more popular, we had a lot of discussions within the community. So there were bold claims that this is just not important, so just less than 5% globally will engage in remote peering at IXPs. Some IXPs claimed back in those days that this is actually a risk for the resilience of the interconnection, and a lot of claims, but we got the feeling that actually we need more substantial data, and we also need a tool, an algorithm, or a process to really identify at scale how dominant or not dominant remote peering actually is. And so we kicked off a research project which finished a couple of weeks ago, and we published this paper at an internet measurement conference where we summarize all the results, and I'll just give you a quick overview of what we found here. So as I said, our motivation was, at the end of the day, what you just have a cable or a fiber, right? And the question is, what goes beyond that cable? So actually you don't really know where it terminates, where the next router physically sits, right? Is it in the same data center? Is it some in the metropolitan area, or is it at the other side of the earth? And we believe that it's good if we would build a mechanism, a tool, to just get more transparency in that, and to identify remote and local peers, like from the outside, right? And for both IXP operators and customers, this could be a benefit, because then you can optimize your routing or your understanding actually where the other end is sitting. And we also like to understand the features of remote peering. So simply said, what does remote peering to the internet and to the interconnection landscape? So, and the first thing we actually developed was an algorithm to really infer remote peerings, as I said, from the outside. So the idea is not, if you're running networks, you know where you are remote and where you're not remote, and maybe the other end knows as well. But from my IXP perspective already, it's sometimes I'm not able to say where the network's actually sitting, whether they are remote or they are not remote. And the algorithm should decide whether a network, based on the measurement we do, is remote or local, and there are also instances in which we can't really say, so where our algorithm doesn't deliver a certain result. And first step is rather simple. Let's just focus on resellers, coming from the assumption that reseller customers are remote, and also if we look at the bandwidth, we know that, which bandwidth are sold at the IXP, and if it's fractioned, and in particular if it's less than a gigabit, then this is an indication that this could be remote peering. If we combine this with the extensive RTT measurements, we also looked over a long period. So if we see within 6 months the lowest RTT value, we know that this is basically the closest physical distance we can get. I mean, because outliers lower outliers are impossible, right, if we look at physical distance. The next was, we wanted to identify multiple IXP routers, so sometimes one router peers at multiple IXPs, but it can, in most cases, I mean in some cities are multiple IXPs, but in most cases this is not the case, and one IXP can just be local, so the network can be local to one IXP but not to all of them. And we localize at the facility level the private interconnection. So what we also do is, we combine the trace route and AES to facility mappings. This comes from our previous work, where we try to really map AESs to facilities. So if you say there's an Equinix data center and really down to the facility, meaning building level. And if we combine all this data at the end, we're going to have an indication. So, and we do it step by step, and as soon as we have a clear result, we stop the algorithm. And this is basically the result of our inference. You see a good number of IXPs on the x-axis, and on the y-axis you see the distribution of the members. And we have the unknown, remote, and local categories. And you see for the IXPs here, overall, the yellowish one are the remote peers. And we see actually visibly this is a good chunk already, right? So a lot of ASs at IXPs are actually remote. And if we average it across all the IXPs we looked at, we see that 1/3 of the members peer remotely at the IXP, at the given IXP. What we also see that 90% of the IXPs have at least 10% of their peers as remote peers. So this is not something small or something we can neglect. This is really a big basis of customers that actually does the remote peering. And in particular with the larger IXPs, you can see in our graph or in our plot on the left-hand side is that there are up to 40% of their peers are remote. So, and our explanation for this is if an IXP grows in a metropolitan area, they're sort of convergent because there are not so many local networks anymore. At some point in time, most of them probably have joined, and the number of networks in this market is not growing that fast. So if the IXP still wants to grow, it can do it mostly with remote peering. And this growth brings me to my next slide, where we looked at 5 IXPs for about 1 year. And there we found with the green line the growing number of remote peers over time compared to the local peers. And this really is evidence that actually for those IXPs, and in practice it's rather the bigger ones, that we have the growth that we still see in number of peers. This is in irrespective of the traffic actually. We see that remote peering is the most traffic, most new peers coming from remote peering. And but we also noted at the same time that at some points in time also members leaving IXP, so they sort of de-peer the IXP, and we see that this happens faster with remote peers as well, right? And and we believed, okay, maybe they went from a remote peer to a local peer because they opened a new POP in that area, a new location, but we just found that in 18 cases a remote peer switched to a local peer. We didn't observe the opposite, and we see higher join but also higher departure rates. So meaning with remote peering, by design, you're more flexible, right? So the growth and churn is just higher. So some other features. Also for us researchers, we had a PeeringDB talk this morning. So it's a great tool to just get an indication. I mean, we know that everyone has to enter their own data into it, so it's not 100% accurate, but it's a great tool to really get an overview also for researchers. So I encourage you to just use it as a tool, use it for peering, use it for what it's meant to be, but it's also helpful for others. And in this plot, we basically see that the distribution of the port sizes or the capacity basically is equivalent to the local peers, like the distribution looks the same, right? So no surprises at this end, but we also note for the high capacities, we hardly see any remote peering because 100 GE peering remote does not necessarily make sense for now. So, and in the other plot, we see customer cone sizes, and there was just the question or the notion we wanted to understand whether the customer cone size, meaning the set of customer ASs you can reach through this peer, is very similar, right? We see basically no great difference between local and remote peers. Yeah, so other routing implications we have and we found is that in 66% of the cases, indeed the closest the IXP is the closest to the remote peer, meaning it's not that I want to just extend my network and just go to any peer. It's still always the closest IXP we could physically find to this location. And we also found that in 34%, and this is a bit evidence for that some people are afraid of that remote peering increases complexity, even though it helps the flattening of the internet hierarchies. We found 34 cases which do not comply with the expected hot potato routing exit strategy, even though this is just an inference and yeah, just scratching at the top of the topic. So we also built a website where you can just enter an IXP, you can play around with, see which peer is remote, where our inference thinks it actually sits. This is not always 100% accurate, but it should give you a notion and might help you if you're looking for specific networks or you want to see who is at which IXP and whether he is remote or not. So again, the idea to be transparent and to give a tool to the customers. So our conclusion for this part is that we have a new methodology to accurately infer remote peers. Our source code is publicly available. It's written down in the paper how we exactly did it. So I was just barely scratching at the surface to give you an idea of the most relevant or interesting findings. And remote peering becomes popular practice, and it's almost everywhere as of today already. So significant numbers, in particular with the bigger exchanges. And publicly accessible web portal, which could be used to really play around with this stuff and see what we did there. And we maintain it over time then as well. So this is my part for the research with remote peers, and I just have one slide of other stuff we did, just to give you an idea. For us as DKIX, it's also important to not just maintain a reliable and resilient infrastructure with modern services and good pricing. It's also important that we support the community with research and getting understanding of things work at scale. And since the internet is a self-growing system, no one really having an overview of all the routers, right? So we cannot just dump the FIPS of all routers and just look at the current state of the internet routing system, and that's why we need to do internet measurements. And what we also did is DDoS mitigation measurements at scale. So in this publication, we infer BGP blackholing activity in the internet, and the idea was we know as DKIX and probably Msk-Ix also knows about who's using blackholing when and how often it is used and whether it's a useful tool or not, like the limitation it also has. And with this paper, we wanted just to show how predominant is it across the globe, like any network. And this is just a quick wrap-up of our findings, and we inferred that actually the number of either transit ISPs or IXPs increased by about 100% globally, and 18% with the transit ASs, since in transit blackholing is around for a longer time already. With the next plot, we also see that the number of blackholing users increased over our measurement period, so it's basically about 3 years. And we just used the publicly available BGP data to infer this, and we found an increase of 600%. So it's not just more providers, it's also more users globally. And the interesting part is that if we plot the blackholed prefixes in the right plot, we see that it really correlates with public known events. So the a reported in media attack on the Russian government, the Olympic Games, and curbs on security stuff. So if we read in the news, hey, there was a huge DDoS attack, we also see spikes which correlate with that. So we really believe that, it's also used in such major events as mitigation strategies. So internet-wide study, adoption of blackhauling, I think it's a very interesting paper and it's good to read. If you don't have the time to read through the full paper, it's also worth to just jump to the conclusion and just scroll over the different plots. And one other result is also there's a need for more fine-grained blackhauling, because we talked to a lot of operators and had a lot of outreach, and they came back to us and said, well, IP-level granularities for DDoS mitigation by far not sufficient. We have our solutions for traffic scrubbing and so on, but we also would see such things more fine-grained at IXPs. Yeah, and that's it from my side. Thank you so much for your attention, and I'll be around for the rest of the day as well, and happy to chat with you guys, because it's my first time in Moscow, and probably I don't know most of you, and I'd be super happy to just chat about technical topics with you. Thank you.
Thank you very much, Christoph. Are there any questions or comments? Oh, then I have a question. Did I understand correctly that this research is also published as white papers or research papers?
It's published as research papers, so it's publicly available. You can find it on the internet, and it's published on academic conferences.
So IXPs are also becoming an R&D centers, right?
Yeah.
And that's great.
We're trying to, yeah.
That's great. Thank you so much for your presentation.
Thanks again.
Thank you. Да, друзья, мы на самом деле продолжаем.
And dear friends, we are actually ready to continue with our technical workshop, and people are asking me what happened to Alexander Ilyin's presentation. Well, it didn't go anywhere. We'll find a place for it at the end of the day, definitely. But now I want to give the floor to Mark Stokes with links, who will discuss disaggregation in the links network. Mark?
You prefer this? Whatever.
Hi there, everybody. I'm Mark from Links. Thank you for having me here. I was going to try a little bit of Russian, but my Russian is almost zero, so my best I can say is "Dubli din." As you probably know, Links is one of the largest internet exchanges in the world. We actually started in 1994 with an 8-port 10-base-T Ethernet hub. And since then, we've actually grown to what we are today. We have over 800 members. And if we was to count that by ASNs, we have over 850. And in the next couple of years, we hope to reach 1,000 ASNs. And that sort of gives you the idea of the sort of scale that Links has to cope with. So we do provide, obviously, a peering platform. We also do a little bit of co-location. We operate a private peering facility, which has no monthly or annual fees. And we also represent our members about public policy. So we try and educate the UK government and the EU government so they make sensible laws, and just to try and educate those in power. So over the last few years, we've started to attract networks that are not ISPs or content. We are having government networks connecting to our exchange. We're seeing enterprises connect to our exchange. We have banks and new sorts of networks getting into the peering world. So we operate dual LANs in London. So we label them LAN 1, which is powered by Juniper hardware, and LAN 2, which you'll see more details in this presentation. We also operate standalone exchanges in Manchester, Wales and Scotland. A few years ago, we also expanded outside of the United Kingdom to Washington, just outside Washington, D.C., in the Ashburn area. This is also powered by Juniper networks. So it's actually this year, 2018, it's our 10-year anniversary for when we expanded outside of the Docklands area of London. So we've expanded our network now to cover 12 data centers in the London metro area. And as you can see, we have a 65-kilometer sort of metro area covered. So let me tell you a little bit more about why I'm here and the project that Links is proud to be presenting about, and that's our LON 2 infrastructure review. So, as I mentioned earlier, Links is a large internet exchange, and we need to scale our network very large. So we wanted to offer something that would be new, resilient, and we also wanted to do something that was different and that would allow us to innovate, something that would deliver us value going many years into the future. So we started this review quite a few years ago in 2015, where we started to think about the strategic direction that we could perhaps do with our LON 2 network. So what we came up with was a solution that was significantly lowering cost, and it was a big improvement on what currently existed. So what this actually meant in practice is we'd be moving away from having a single vendor that supplies the network hardware and the software. And what this did is, in 2016, we had enough information and enough confidence to be able to slash our port prices on LON 2 by 40%. So the new partners that we found were EdgeCore Networks and IP Infusion. Now, EdgeCore Networks are a Taiwanese-based company. They've been around since the early 1990s, and IP Infusion supplies the software that runs on the hardware. And you probably use this IP Infusion software without even knowing it, because Huawei do license some of their intellectual property. And this was an interesting process for us because we have 3 partners here. So we wasn't sure how well working with 3 different companies, Links, EdgeCore and IP Infusion, how well this would work. So the new solution that we've implemented uses the latest technology. It has EVPN, it uses a leaf and spine topology, and it's all 100 gig ready. And as far as we know, we are the first internet exchange to actually operate all these technologies on a network as large as Links. So let me tell you a little bit more about those new technologies. So the leaf and spine sort of topology, this allows us to scale the network to very large capacities. So we can just add in additional switches whenever we need more capacity. So it's a low complexity design, which means that it's less prone to error and failure. So this gives you an indication of basically the traditional chassis-based design. You can see on the slides here that you have a big chassis, you have infrastructure line cards, you have line cards with member ports, so some cards have got 100 gig and 10 gig. Now the issue is here is if you've filled up your line card and you need to add additional ports, you need to rip out that line card and replace it with one that's higher density. Now, if you don't reuse the one that you've removed, that line card goes to waste. And you also have to disrupt the existing members' traffic that you're going to take away that line card. The new design uses switches as line cards. So each line card is represented by a switch. And if we need to add some more 100 gig ports, we simply throw in another 1U switch and connect that leaf back to the spine. So let me tell you a little bit more. If you've not heard about disaggregated networking before, you are actually familiar with this because it's been something that's been going on in the server space for many years. You can go and buy a server from HP, or you can buy it from Dell, and you're not forced to use their software. You can put on their Microsoft, you can put on their Linux, and if you really wanted to, you could program your own operating system. So this is what we have now in the networking space. So we can choose a technology that's right for us. If in a couple of years we do not want to use EdgeCore, some other router manufacturer creates something that's really cool, we can throw out the hardware, but we can keep all the software. And so this allows us to choose a technology that's best suited to our needs. So EVPN is something that has grown with the evolution of Ethernet technology. Everything on the network is programmed. So all the MAC addresses are programmed onto the network, and this has various benefits for our network. Because everything's pre-programmed, the whole network acts as one giant switch. So this enables us to do some pretty cool features. One of these features is multi-home ports. And now, internet exchanges have been, aggregating ports together for a long time. But generally, those ports have to be on the same switch. You can put the ports on different line cards, but they have to physically be on the same switch. But with our new LAN 2 network and all the new technologies, because the network behaves like a giant single switch, our members can have a port in on one switch and a secondary port on another switch. Those switches might not even be in the same data center, but they just operate as a lagged port nonetheless. And should one of the ports need to be taken out of service, the traffic keeps flowing, but there may be just reduced capacity on the lag. So let me tell you a little bit more about the process that led us to where we are today. You saw that this started in 2015 when we tried to work out what strategic direction. Once we knew that we wanted to go disaggregated and we'd worked with the vendors, we wanted them to demonstrate that the solution would work. And this is what happened in 2016. And like I said before, in the middle of 2016, we had enough information, we had enough confidence to do that 40% price cut. The next phase after this was prototyping. Now, this phase was the longest phase that we took, and we was able to sort of tune the requirements, test features, add new features. And then once we was happy that we had all the features that we needed, we then went through into a hardening phase where we locked everything down and we just tested the features to death, throwing all sorts of traffic at them using traffic generators and just trying to break the thing, find the bugs, so we knew that we had a reliable solution at the end of this process. And whilst that hardening phase was going on, we actually started deploying the routers in the data centers where we obviously going to build the network. And then the migration phase started. So in April-May time, we actually brought up the network-to-network interface between the old LAN 2 network and the new LAN 2 network. And then we could start moving member ports over gradually. And then by June this year, the new network was fully operational, and we disconnected and switched off the old LAN 2 network. So we're now working with IP Infusion and EdgeCore just to add a few sort of enhancements in regards to automation and to just get the new features that we want, like multi-homing. So what does this mean to the marketplace and to you people in this room? So we think it's quite important for the industry what Links has done. Links is one of the top 3 exchanges in the world. We have a lot of exchanges that look to Links because Links has the resources to be able to invest in projects like this. So we've had lots of interest from internet exchanges all over Europe. The LAN 2 network that we have in London, it is smaller than the LAN 1 network. It has about 300 members connected to it and 0.5 terabit of traffic a second. Now that's still quite a lot of members and traffic, and it's quite a lot larger than many internet exchanges that exist in various parts of the world. So smaller networks at links get a brilliant benefit to this because EVPN stops unwanted flooding, and those smaller networks with smaller capacity ports no longer get congestion if a flooding event occurs. And for larger networks, obviously they can take advantage of our multi-homing features, and they also are very pleased to see the price reductions that this newer solution provides. And because this box, we have lots and lots and lots of switches now to manage. The solution was built with automation in mind from day one, and it uses netconf to push that configuration out. And the modules that Links has written will be available on GitHub. So, we want people to copy this and enjoy the success that we've managed to achieve. So I believe that was a lot of slides. I think that's 42 slides, and I hope I've done that in the time limit that we needed. And I wondered if there's any questions, but I have forgotten my translator, so I may need a bit of help.
Друзья, если вопросы какие-то.
So, dear friends, are there any questions to Mark? Тогда у меня есть вопрос. Мы знаем по собственному опыту, что участниками IXP могут быть совершенно разные компании и клиенты. Кто те люди, те участники, кто будет пользоваться этой вашей новой сетью? Да все будут пользоваться. Мы должны осторожно подходить к нашим бюджетам. Есть и другие интернет-эксченджи, и сегодня рынок перенасыщен, по крайней мере, в Лондоне. Но сегодня, например, банк Lloyds пирится через Links. И мы видим другие предприятия, которые перенесли уже критические для бизнеса приложения в облако. Они тоже интересуются нашими услугами, им нужно надежное интернет-соединение. Я думаю, что в ближайшие несколько лет мы привлечем еще больше таких... То есть банки... Да. Вы знаете, что Лондон является хабом для финансовых технологий, и понятно, что есть какая-то такая там learning curve, когда нужно сначала приобрести знания, уверенность и так далее, но нам нужно как раз помочь всем этим компаниям, во-первых, заинтересоваться, а во-вторых, почувствовать себя уверенно в этой теме. Спасибо большое, отличное выступление, и вам тоже большое спасибо.
Да, спасибо Марку еще.
We want to thank Mark once again. And our final speaker in this session is Alexander Ilyin, the technical director of Msk-Ix. We broke the tradition of the last 13 years. We changed the order of the presentations, but the spirit stays the same. So Alexander will say a few words on the future of the Msk-Ix Pirion platform. Well, we not only changed the order of the presentations, but also, you see, I changed my appearance a little bit. I hope you like how I look like these days. Anyway, let's go quickly through the main technical changes that we've incorporated into our operations in the last year. My presentation will be quite long. Well, anyway, I'll try to keep it short somehow. We'll start with main services, and now we've fought for it, and now we are capable of delivering 100 gigabit everywhere. It was expensive, it was unavailable, there was low density on the ports, there was equipment that, the vendors promised that this equipment would have 100 gigabit. It never happened, but now 100 gigabit is mainstream and standard in a way. So Moscow, St. Petersburg, Yekaterinburg can have 100 gigabit. Those are the places where we already have solutions, and in other cities we can implement that quite quickly. We keep all the hardware in stock. It depends on you and your needs. We use the new platform for it, and we can set up several 100G ports in one leg. This is something that has already been said today, and I would not want to repeat what other people said before me. We talked to many vendors, we insisted, we tried to explain why IX wants to have all services in one port, all in one, and we managed eventually to get a unique solution from the vendors today. Different services are available on the same port. We know now how to count VLAN statistics. Not all vendors actually have available statistics, and it's not always possible to get it quickly. Another interesting thing here is that apart from saving on the crossings and communication lines, we also know how to set up quality of service. And we use that in media logistics very actively, even on high-load ports with big volumes of traffic. The time-critical packets for media logistics are never lost, and it works very well. And there is a lot of positive feedback for the quality of service that we offer today. Infrastructure. We talk a lot about our infrastructure. We discuss it every year. We built 2 cores to kernel network. There are 2 energy-independent sites now, non-volatile sites in Moscow. We are building around those sites. We are building infrastructure that would support multiple 100 gigabit ports, but would be flexible at the same time, ensuring future expansion. The process is ongoing. It wouldn't happen overnight, but we are working. This is what we had in 2015 when we started to build this topology. Over there you see several layers, tier 0, tier 1, tier 2. Depending on the level, on the tier, we use different scales, different hardware, and we developed the sites in line with this topology. But what we have now is the snowman, a wonderful, lovely snowman. To migrate from one core to the other without interrupting the whole network is a challenge, but our job is not to lose a single packet, ideally. So that's why very cautiously, very slowly, we implemented a 100 gigabit core, which runs on 2 independent data centers. They're shown here, DC1 and DC2, but at the same time, we realized another interesting thing. A 100 gigabit solution at long distances are kind of heavy, kind of expensive. It would be reasonable to take key data centers which incorporate a lot of switches and that would be aggregated into another kind of key data center. That's why we have here this 3rd component. It's not a secret that we are talking here about the M9 site. Eventually, we arrived at a very stable, reliable, and redundant scheme, which will allow us to migrate to a new 100 gigabits core while gradually disconnecting the very old core. A lot of automation, many processes, we try to make them simple, we try to make them available, accessible. Get into your, personal account, you order a new service, you connect to media logistics, you set up your channels or media signals, whatever, and we try to expand those features. If you have any ideas or wishes, could you please inform us, tell us about tell us about what you need. One thing that we have already done is managing your BGP sessions. If, for whatever reason, your site is unavailable, you can suspend peering via route server, and you can send a command, and it will be executed almost online. You will see there will be some latency, but you will see that the session is down, and you will be able to carry out maintenance or whatever you are doing at your site. But of course, this list of those new features will continue to expand in the future. The Internet Exchange itself, the route server, we implemented a number of enhancements of Looking Glass. Our Looking Glass is popular not only among colleagues in Russia, but also outside of the Russian borders. It provides a lot of information. Many actually find it useful. In the last year, we implemented a mechanism to protect against different errors. There was this interesting error when we saw an AS path longer than 64 ASs, and some routers, some hardware couldn't manage that, but now it's filtered, nobody suffered, so our security mechanism paid back. And community, a lot of filters for the maximum number of community. You know that we now have all these new filters. Another thing, we work actively today on RPKI. We keep deploying it. We don't want to lose traffic. We do not want to lose error prefixes. That's why we're working with the members who have problems with that. We sent out emails. We organized automated mailing, and we are one of the I mean, our Internet Exchange has one of the first automatic mailings like that, where we ask the members to fix invalid ROA. RPKI, a couple of words for you to understand what that is. You have one connected member, a route server member who connected a customer with an announced route from one autonomous system, but then suddenly the same route is announced by another autonomous system. If this route is signed, then we know not only that this AS has this prefix and it's valid and it belongs to this AS, but also its sizing is identified. You can say that this is a prefix /16 to 24 is valid, and the other ones are not acceptable. They should be rejected, and they will be rejected. So this implementation blocks off and doesn't let this kind of traffic pass through. Right now, we are not blocking the invalid traffic. We analyze it and we send out the information. Statistics on RPKI. You can see the numbers on the slide. There is valid, non-valid, and unknown routes. You can see the numbers. And if you do your math, you'll see that we have 9% of all route signs in Moscow, 11% in St. Petersburg out of the total number, and will not be taking any drastic measures on it as long as we are fighting invalid routes. We are lowering the local pref for invalid routes as a countermeasure, but since it's still present on the route server, it returns with a lower pref. Looking Glass. This is what Looking Glass does. This is, I mean, you can go there and see for yourselves what kind of information it provides, including diagnostics, RPKI, and other stuff. Hurricane Electric. That was an interesting experience, which returned a lot of prefixes. We tried to keep it under control, and to somehow influence the Hurricane Electric and the participants so that the process would run smoothly. But it was still noticeable. How noticeable? Some of the members realized suddenly that the equipment is no longer sufficient, that there is not enough memory. They started filtering the routes partially. Some of them were under the max prefix limitations because it was a real jump surge. We know that people contacted us about replacement for old Cisco's because they just couldn't fit into the new size of the routing table. But we helped everybody, and I'd say that overall that experience was quite painless. Media logistics. Really, we have a lot of signals that people spoke about already. It's difficult to maintain high quality of service over long distances. Grigory showed you a map with our locations all the way to Vladivostok, but real-time signal, that's a big problem. It's a challenge and hard work. We among other things, we are improving the mechanism of error control so that our remote members receive the highest quality possible. We implemented all kinds of flow redundancy mechanisms. We automated the subscription mechanism. We monitor and we transcode the signals, and we also carried out analysis of the network for micro losses. The micro losses and for IP traffic, they are not important, but for real-time traffic sets very high requirements to the quality of the network, and Msk-Ix had, like I said, work real hard on expanding our network and enhancing it. Media logistics, you see all the signals, distortions, kinds of error, the number of errors. Our own operators see thousands of TV channels, and they record all the errors that they see, and the bit rates and everything. The DNS infrastructure. We are not standing still. We developed the DNS clouds that we built. We built and we opened new nodes in Novosibirsk and in Auckland. And recently we were focused on the public resolver. Probably you don't know, we have this DNS-ix.ru and DNS2.ix.ru. They are publicly available and you can use them on every system. We want to make them very easy, very simple and fast for our members primarily, but also for everybody else. So anyone who's using DNS, they should have fast access to those two resources. We also implemented DNS over HTTP and over TCP. Dim Bilyavsky spoke about that during the morning session, and we are in the process of analyzing this experimental deployment. This is an example of the settings. But if you're interested, you'll be able to take a look at the slide when you download the presentation. The quality of service, QoS. We had another partner, Microsoft, suddenly said that they would be switching to private sessions. And it turned out that some of the members cannot or don't want to write a letter in English or to fill out the template that Microsoft offers on their website for peering, and apart from all kinds of information, you also have to identify yourself. You have to state your account from PirnDB. As it turned out, nobody had a PirnDB account, so we established this communication with Microsoft, and we reached out to our community, which also enhanced our communication with PirnDB. Among other things, we are now uploading our members' information via JSON to PirInDB, and the other way around at Ix, you can get information from PirInDB on the member and also the looking glass that is also downloaded rather from PirInDB, and also the translation into Russian. We translated the interface, but we are at the stage of it being implemented onto the main platform. User's account. We automated services. You can now order hardware. You can order signals, and we hope that it works for you just the way you want it. In the last year, we also worked on standardizing and certifying the solutions that we use and the actions that we make. We were highly rated. We entered MANRS. It is a project that initially united telecom operators. Now it also brings together internet exchanges, and it regulates the quality of service, basically. Manners says that we must comply with a certain standard to be at the top, to provide the services at with the highest possible quality. You can find more information at the Manners website. You will see which actions we support. You will see Msk-Ix there. And we were also standardized, we received an ISO certificate. Apart from a lot of implementation projects, we are also testing. We test all kinds of equipment. We bought Ixia equipment that not only generates but also analyzes the traffic. And we study every new piece of equipment to understand what mistakes or failures might occur on this equipment before we start operating it for real. We analyze v4v6v multicast DNS as well. We work a lot with vendors. It usually happens behind the scenes, but as we test, as we implement, we hold a lot of discussions with the vendors. And it helps us to build quite complex filtering systems and to make our platform more secure. Thank you, and I will be very happy to take your questions now. Colleagues, are there any questions to Alexander? Yes, please. Please don't forget to introduce yourself. My name is Maxim Raevsky. I'm with EV-RU. I understand about 100 gigabit. What about 40? Well, we've been talking about this for several years. We saw that there was totally no interest to 40 gigabit. And we realized, well, now we are interested. But you are the first ones to tell us. But yeah, we can talk about it. Why not? We have the equipment. It's just that in the global community, the demand for 40 gigabit is non-existent, basically. But we would be ready to find a good solution that will fit both parties. Yes, please. We have over here a question. Sasha, what about 25? I mean, I'd love to see the full range. What about 25? 25G. Well, 25G mainly is for data centers. 25G standard initially was intended, servers for servers 40G is expensive, and 25G is a compromise. It's not a very expensive but well-performing solution, but it's operators, not servers, connecting to Ixes. It's big networks connecting to Ixes. That's why there is no demand at Ix level for 25G, but if there is demand, we will be able to buy the required equipment. Okay, thank you very much, Alexander. Let's thank Alexander. So you see, now we heard from different IXPs, but all the innovations and all the efforts don't make much sense unless there is demand for those services. And during the remaining time of this session, we'll give floor to the customers, to the clients. We want to hear from them what tools, what mechanisms they want to ensure successful connectivity. Please welcome Jan Cleary. This session was supposed to have been finished by Sergey Mitin, but you've never seen a Sergey Mitin like this before. Please welcome Sergey Mitin's avatar. He'll explain why this happened, actually. Hello, everyone. I want to welcome everyone who joined us for the second part of the Pirion Forum. First of all, I want to apologize on behalf of Sergey Mitin. He is not here today with us, but during last night, we want actually to thank our builders. They caused Sergey to work during the night fixing the problem that those builders inflicted upon our office. So right now he's in no position to talk. He's sleeping back home. That's why he asked me to make the presentation on his behalf. And I have to apologize again because these are not my slides. So maybe I will not be able to tell you absolutely everything that Sergey would have told you, but let's take a look at RUNET. How big is RUNET? If we consider the prefixes, for us, our biggest part of our operations are in Russia. RUNET is very important for us, and you probably know that today a full view is approaching 1 million. There are about 720,000 prefixes, sometimes more. Sometimes I read about 830,000 prefixes, but the average number that I've seen is 720,000. Russian operators, depending on where you measure and what you take as a RUNET criterion, it's 40 to 60,000 prefixes. For the purposes that we use in our calculations, let's say 53,000 on average, but they are not, strictly speaking, Russian prefixes. This is a RUNET. The way it is labeled by Russian trunk providers, these are the prefixes that they are getting in the Russian territory and their customers' prefixes as well. That was 7% of the global routing tables. So 53,000 prefixes. How can we see them? We see some of them through peerings. We see others through upstreams. And we counted this here. That's what we see in different internet exchanges. How many of these Russian prefixes are associated with various Russian big internet exchanges. The number one, I think you know who the number one is. Math is quite relative because, again, we need to remember about all this reservations that are made about how you count the size of the Russian RUNET zone. So this is a pie chart that we get on the traffic, but when we talk about theory is all very well, but practice is more important. If there is an external pressure on the service, a major external pressure on the service, what happens during DDoS? Could you keep it alive? There was a day, it was not even a Friday, instead of lunch, on our graphs, we saw something rather curious, this one. Normal traffic during peak hours is shown to the left. What you see to the right, this is not normal. This is lunch hours. And then suddenly we were hit from the back, and we thought that it was an instrumental problem. Someone made mistakes in Zabbix and started multiplying the traffic, but we ran a check. It showed that it was not a mistake, it's real traffic. But if traffic grows like that, that means DDoS. We are being DDoSed, we are being attacked. First graphs, same time scale. This is the applied measurement. This is the number of viewings that take place at any moment in time. Every 4 minutes, I think, we take the measure. And although traffic went up, which is really a DDoS probably, but the viewers had still unhindered access to EV. We ran cross checks and we said, okay, if this is the case, if the viewers are not affected, then how come we're still alive? Two factors. Almost half of the traffic we do not send upstream because they have their own limitations on their capacity. We give it to peers via exchanges. Another factor, which is shown on this slide, is our distributed regional network of caches. So this ladder-like curve was spread out across the country. Every region saw an increase, but not to the extent that would block off or plug the network. And then something even more curious happened. It turned out that, yes, it was a kind of a DDoS, but it was managed from inside of our office. On this day, 3 minutes before we saw the surge, for one of the TV platforms, we updated the file with their playbill, with the TV schedule. And everywhere around the world, all TV sets, all smart TVs started updating those schedules, TV playbills. And it turns out, going back to Internet of Things and smart TV, actually, that community set up a DDoS attack on us, basically. We still don't understand what in our script caused such a reaction, because we did this before and we did it afterwards, but without an effect like this. Smart TVs are actually still a black box for us. So, two takeaways. We diversify our connections between streams and peerings. We have an open peering policy. Our workload is spread out across the country. And because of that, we can survive cases like this one. And I want to thank Msk-Ix for making their contribution into our survival. Thank you very much, Maxim. That is a very instructive case. Any questions to Maxim? Thank you very much. So it means that we can announce a coffee break now. A coffee break will be until 4:30. And at 4:30, we will start a new session where we will talk about the future of our industry. There will be discussions, panels, and the rest. So it's Okay, dear friends, please enter the room and take your seats. We are starting now the final and the most exciting part of our forum, a session on the future of the industry, as Yelena has already mentioned, and other speakers after her. Telecom operators today only partially remain telecom operators, communications operators. They are all progressing towards managing data processes and information. They become service platforms and IT companies. So we will be talking about this IT transformation. The only thing is, you need to understand that this transformation, it happens not in a vacuum. Instead, it happens subject to a number of factors, including regulation and business factors. So what is the place of infrastructure operators? Operators of technological platforms in the world. Let's discuss that. The first speaker is Vitaly Selizin. He'll talk about cloud storage of big data. Very good day, everyone. Good evening, I guess. Already it's a Friday night. Since it's Friday and it's kind of late in the day, even I decided to come here without a tie. I was told that I shouldn't wear a tie today. Okay, let's get started. When I was talking to Msk-Ix about my potential presentation here, we looked for different topics. I don't know whether in my presentation you will get the answer to the question that I state in its title, but I agree with the person who spoke before me that today the world is changing and quantity becomes quality, IT is changing, everyone is changing, even Google is changing. So before you discuss a topic, you need to start with a definition. We need to define what we are going to talk about. So two things: data, big data, super big data, and SLA of access. I think both notions will be hard to define. Quantitatively, rather qualitatively, would be a better approach. SLA. Now, to me, this seems more easy, like an easy option to define. We think that obviously, I mean, we are at the point when SLA in the cloud should be on par with SLA in LAN, local SLA. As to data and big data and super big data, how big is, I mean, we all know one to many lots, but where does it start with many and lots? How many is that? So for the purposes of my presentation, I mean, you can see here all the main characteristics of what can be considered big data and what definitely cannot be considered big data. A long time ago, around 2009, I was invited by our colleagues in Samsung to go to South Korea. So we're in Seoul, and yes, we went to different data centers, and we're in Seoul listening to this very sad story that the degree of digitalization of the economy in South Korea is such that should North Korea hit Seoul, and they can do it within 12 hours using small caliber guns, there will be no South Korea left. And we are talking about losing data centers. I mean, all the fields will be there, all the ships, all the rivers, everything will remain as is. But without the data centers, there will be no South Korea. It's a legend. I mean, I got it from Samsung, and now I'm sharing that with you. It's a legend, and I asked my people to search for it online, but they couldn't find anything. But the South Korean people, during the years that are listed on the slide, managed to create a digital image a digital copy of the digital economy and locate those images in 2 data centers in New York. And the guaranteed time of recovery from the data centers in New York for them in those years was 6 hours. Anybody heard that urban legend? Anybody? No one? Well, I heard it directly from Koreans. If you come across this legend, please share that with us, because I'd love to find proof for it sometime. Can that be, that feat, can it be replicated? Can it be repeated? Well, on the country level, yes, some people already doing it. Syria, Iraq, Egypt. I mean, all these cases, they teach us all a lesson. We must learn the trick of storing data in super big data somewhere abroad, ensuring a certain SLA for access. Corporations, yes, they can. Some do it already, others don't. And the rest of us, no. At retail level, no, that's not possible today yet. But enterprises, of course, businesses have this need to store data and big data, and I can't guarantee to you that all specifications of types of data that's listed on this slide are they will fall within the subject matter of my presentation, but I guess 80% of different kinds of information listed here fits the description of big data. What do we have in the Russian market? The market is very segmented. There is still uncertainty about network neutrality. When I spoke before on the subject of network neutrality, in the context of SLA-based storage, I don't know. It's a matter of philosophy. Actually, Yakovshev is here, and you remember what we were told at the universities. What is truth? Truth is the class type idea of truth. So I don't know whether there is truth there or there is only an idea of truth. Well, probably we need to have network neutrality, but with different signs. Certain types of resources should provide access at much lower prices than the price of access to other types of resources. So it's a big question mark for me. The third item on the slide, I can't advertise myself, but really, in the last 2 years, we have seen an emergence of several interesting platforms, both on the hardware, on the software sides. I mean, domestic platforms. I'm not talking about HP. I'm not talking about redesign of Huawei. I'm talking about local Russian projects, high-tech. I think the storage systems are called Telecom something. Never mind. Item 4. The market is stable. Svязь was the last big player, but that was a long time ago. I mean, it was the last big player who joined us over the years. So I don't expect any tectonic changes in that market. But the market is really big in terms of volumes of data stored. I read on the RBK website once on the front page that there will be a shortage of data centers in Russia soon. Have you read this article? Yes. Of course, you should have read the last paragraph, because the last paragraph contained the essence of this article. Data line, it said, will win the market if there is shortage of data centers, because they sold 1,300 racks to Sberbank's data center. But really, there are data centers built all over the place, and they are populated very, very quickly. Next item is about trunk prices. Russia is not Luxembourg. Russia is a vast country. So we should remember about trunk lines and the prices. If, like 3 years ago, we were saying here that the prices are on the verge of payback level, but today those prices do not pay back, neither for fiber channel nor for hardware-only consortia or some shared resources. Actually, that's the only solution. When you collect all possible contributions into one piggy bank, if you will, and then share it between all participants. Next item. Everybody's talking about the Yarvai's law and the petabytes and exabytes of storage. And on the other hand, which is even more important, new players are coming to the market in the Forum world that have from the very beginning offered SaaS and cloud storage. So the conclusion is we need evolution, and mice should become hedgehogs. What do we have today? Well, we are somewhere midway between mice and hedgehogs. To your left, I mean, this is a real animal. It's a real animal. It's an animal, I guess. It's a hedgehog without needles. And the Englishmen are giving it tender love and care, trying to encourage it to grow needles. But jokes aside, we know that in the market today there are many products for cloud storage, for big data, but none of these providers offer an SLA. Today there is not a single product in the market with a good SLA. Yandex Disk with SLA? No, haven't heard about it. Google Cloud with SLA? No, never heard about it. Even Dropbox. We haven't seen an SLA from Dropbox yet. But we are midway, like I said. So on a high level, on an abstract level, if you do not think about SLA, but rather about access cost is negligible compared to storage costs. Is there a solution to this conundrum? Of course, there is one. You don't even have to change the paradigm. All you have to do is to get together during coffee break, for instance, like people at an event like this. Vertical integration is the only thing that can ensure a breakthrough in the market. So over here, it's our little private joke on Rostelecom. They are doing a great job, actually. They are the only vertically integrated company in Russia that has its own technology and infrastructure at all 4 levels that big data storage requires. They have their own access networks, they've got trunk lines, they've got data centers, and they have equipment. It's just that we couldn't find what kind of equipment Rostelecom uses, so we decided that we'll use that image as a placeholder for that equipment. We guess they have something, probably something good. Going back down to earth, just to give you an example of why we might need that arrangement. This is a private case, a particular case. A customer from Yekaterinburg, disaster recovery as a service for big storage, 60 terabyte. That's quite a replica that is required to restore infrastructure from the cloud. If not for vertical integration of the local provider in Yekaterinburg, the operator of data center and the trunk route provider and the supplier of storage machines, the case cannot be cost efficient. It can't be justified. There is no business case for it. And besides, organizationally, it is also very difficult to bring together all the disparate parts of this service. But we managed to do it, and this is quite a typical case for the market these days, and it shows that in the next 12 to 18 months, should data centers develop as they do today, and should the infrastructure stops being on-prem and becomes provider supplied, most likely there will be more and more cases like this, and we will learn how to efficiently store big data in domestic clouds with a good SLA for access to them. And if this happens, then we'll be able to expand business applications usage, we'll expand the coverage of our markets, and we'll start making more money, basically. If you count all the numbers on the slide from this particular case, I mean, I think we were looking at 91,000 rubles per month. That's how much this service cost for this customer, and with this specification. Of course, there are still a lot of questions left unanswered as yet. Often we don't have time to answer these questions, or probably there are no universal answers, or silver bullet, like one recipe to answer any particular question. A vertical integration or a solution like I showed you one slide before last one, probably they are all components of answers to these questions. And I think that's it. That's it from me. So thank you very much, and I'm done. Thank you, colleagues. Any questions? As you are thinking, I will take this opportunity, since I'm already holding the microphone, I'll ask the question. The companies that you mentioned, almost all of them earn not on data storage, but on information management. For them, data storage is a subsidized activity. Who will pay for data storage with an SLA? Here's a case. Here is your answer. A customer from Yekaterinburg. You all know disaster recovery as a service. Vim Online makes a copy of all information resources, and at the time when the infrastructure in the office fails, everybody switches to VDI. And this copy that's stored in the data center at the operator side becomes active. Yeah, maybe, well, my question, I didn't phrase it correctly, but who is going to pay for super big data with an SLA? Okay, what is super big data? Going back to the first slide, in case of South Korea, I think you know who paid for it. South Korea paid, the national government paid. As to Sberbank, 1.3 billion euro, I think they invested into the data center and into the infrastructure for storing Sberbank's super big data. This is a lot of money. In case of corporations, I think, since this is not anything new for the market, it's just a new flavor of what already exists, what people are already using on the LAN or at local data centers. It's an economic question, really. I mean, people are already paying this money. It's just that the recipients will be redistributed. There will be new recipients for the money. Questions? Microphone. Please introduce yourself for those who are watching the broadcast. Hi, Gleb Yuzhov from the IoT Association. I'm looking at this business case, and I don't understand. If 30,000 rubles, how much you pay for a dedicated channel from Yekaterinburg to Moscow, and 1,000 rubles for active IS, why do we need, why this company has a need of its own infrastructure? Of course, they don't need to have their own infrastructure. And yeah, you are absolutely correct. And this is our future. But people need to realize, you see it, but they didn't see it. They still don't see it. When people started building data centers in Russia and everywhere, data centers started popping up like mushrooms after the rain, is when things started getting really bad in the economy. People didn't want to keep their own assets. They wanted to buy services. The same with computers. Like, who needs computers if we have tablets now with big screens and RDP? But we still have computers. We still have desktops. I'm surprised. I don't have a desktop, but I know there are people who have desktops. Well, probably it will happen sometime. Well, thanks. But if this is how it's going to happen, then all IT infrastructure will be transformed. Exactly. From mice to hedgehogs, I think it will neither be mice nor hedgehogs. But what happens to other players? Who? Integrators. Integrators will integrate for data center operators, of course. So they will all settle in Moscow. Well, that's a good question. You can't fight the speed of light. Your question is absolutely correct. From Moscow to Yekaterinburg, it's 23 milliseconds using direct cable. From Novosibirsk, it's how much? 58, 62 milliseconds? So you can't move a certain class of services to Moscow. But only Moscow can offer SLA today. The Russia cannot. No, it doesn't matter. But they came to Moscow. Who? Yekaterinburg customer. Because only Moscow has the most advanced data centers today. But as soon as this paradigm changes in the market, and when there are normal data centers with normal IT infrastructure, the racks in Irkutsk, it wouldn't matter. The market will not change. But if Dataline or Rostelecom comes there, and this is what they want to do with their IT infrastructure, there will be channels from Novosibirsk not to Moscow, but there will be channels to links to the closest data center. Thank you. Thank you very much. Our next speaker. Well, our next presentation is called Schisma of the Genre. As we were discussing the contents of this presentation with the speaker, I was enriched by a number of new terms. So, Anton Bogatov, the floor is yours. Hello, colleagues. There should be some kind of a succession between the speakers. So, following Mr. Slizin's presentation, I will base my presentation on the idea that there is no truth, there is a class's idea of the truth. Well, actually, this applies directly to what we all do. I will be talking about some very sad phenomena, but I'll try to be optimistic about what I am going to say. There are reasons to be optimistic. As far as I can see, because of what I do, I am in direct contact with government regulation and regulators. And for a long time, Russia, the industry on the whole, has developed a negative attitude to government regulation. Nobody likes good regulation. If the regulation is good, then nobody likes it. But the problem arises when the regulation doesn't pursue any clear goals from inside the regulator. Often this is not obvious, and the regulators believe that everything is fine and the public and private interests are in balance, everything is okay. We all know what we are trying to do, but the market, the industry sees this completely differently. We see that there is a disbalance between private and public interests. The fundamental definitions are not defined, too many different rules, and nobody understands what the government wants or what we want the government to do. The industry goes through a stage of economic concentration, and it's not clear whether telecom is at all a cost-efficient activity. But this paradox of government regulation in telecom can be easily explained. The government is not interested in telecom. The government is interested in telecom in content providers, and content providers migrate along networks, and they migrate across jurisdictions. If it's a network, the regulators know how to fight that. What about if it's jurisdictions? The regulators of different countries can come to an agreement. But when they do both, they migrate both along networks and along jurisdictions, we face the Durov phenomenon. Regulation is a written text. There is a requirement posed to this written text. The text must be clearly defined. Subjects, objects of legal relations must be defined and differentiated. If this principle is violated, then we end up with a schizoid text. It becomes fiction. Law becomes fiction. Is it a good thing or a bad thing? Big question mark. In terms of the enforcer who knows who thinks he knows what he's doing, it's good because a law enforcer can use this text and interpret it any way he sees fit. For every subject of regulation, this is not very good because subjects of regulation do not understand the rules of the game fully, they don't understand what's expected of them, and they don't know what can be expected from them in the future. Of course, violating this principle of clearly defining the regulation logic helps us on this, as points to the fact that anything can be regulated. And if Moscow is in London, then 2 by 2 is 7. Over here, we see an interesting effect. If you read a lot of legislation and regulation in the field of communications, you will notice one thing, or several things actually. Our legislation is illogical. I'm not talking about the revised law, I'm talking about the whole structure of norms, all the inconsistencies and controversies inside the legislation. Our legislation is ambivalent. What is ambivalent? That's inconsistency of motives and states. It's when you love and hate at the same time. The same applies to the Russian legislation. I think you'll be able to find a lot of proof of that. And there can be effective inadequacy. I mean, the response can be, it's absolutely unpredictable. And autism. Our legislation is autistic. That doesn't want to know the world outside. There is a quartet of Blailer. Blailer is a German scientist who came up with the indicators of schizophrenia. The government is an entity that can become sick. It's conscious or it's it's a sense of justice, legal conscience can become sick. The illogical and ambivalent nature of our law. Just look at the revised law, and where also there is autism and inadequacy. I think you will not disagree with the fact that this is really a fact. Where can that lead us to? The revised package and filtering, and we talked about, and this is what there were many predictions, there were many speculations about that. Weber-Fechner's effect is well known in psychiatry as well, which says that the perceived intensity of an agitator is in proportion to the logarithm of the intensity of the physical intensity of this exciting factor to the threshold of its perceptivity. And what follows out of this is that every subsequent regulatory action should be several-fold more intensive, otherwise it will not be noticed. We have a lamp with 2 bulbs, and you add 2 more bulbs to the lamp. The luminosity will double, but if you already start with 14 bulbs and you add 2 more, probably you will not see an increase in luminosity. But if you add 14 bulbs to an existing 14 light bulbs, that's when you will notice the change. But, the regulator knows about that, and every subsequent regulatory action, by definition, will be more intensive than the previous one. In case of IT, most likely there will be in the storage systems, the mandatory search engines. You don't know how to do it? Well, it's a technical issue. Or build 3 perpendicular lines, draw perpendicular lines that will be perpendicular all to each other. No, you can't do this. But then they will tell you to draw 5 perpendicular or mutually perpendicular lines that would be green. what do we do if regulation becomes schizophrenic? Well, there are two solutions, really. One solution is do nothing. The other solution is to start complaining. Well, the first exit strategy is also a complaint, but you're complaining to yourself. You are being tolerant. You say that schizophrenia is another norm. Well, justice is a neuroleptic, and I don't think that because of how contradictory the norms are, you can substantiate anything. In court, you can prove anything, so it doesn't really make sense to complain. And the third strategy is exiting or fleeing. To do nothing, you need nothing. To use the second strategy is it requires from you language. You need to use language to complain. But to use the third strategy, fleeing or exiting, not exiting the business, but that also requires a mind. There is a business case and there is a legal description of your business. And the economic content is primary. It would always be primary. Every law defines what's possible and what's acceptable. The government can force you to abide by its rules. And the government can tell you, okay, this is the continuum of possibilities, but only that green area is the approved one. And inside that green area, which is an acceptable opportunity, you can exist. You can create substances inside that area. You can contract, you can do whatever, but you have to stay within the green limits. A legal description of the same thing can differ, and they do differ. And if you don't like the legislation that's applied to your economic activity, you can try to use another description. You can try to find another description, and it's something that is often practiced. It's just that we don't do it. It's practiced, but not here, not in this country. You have to understand that any economic activity is described by a number of legal means. The important thing is to find the right description, which is hard. And that's why you can find a property of your economic activity that does not depend on its legal description. It's a property that will be important regardless of the description, and no one will touch it for whatever big reasons. You are driving a car and you need to get from point A to point B, and although you are in a rush, you will not be riding on the pedestrian streets. You can break, say, the speed limit, but you will not drive over the bodies of people to get from point A to B faster. In fact, you can read about it in any book on economics or on accounting. Economic activity is an interaction between economic forces and economic tools. You've got employees and you've got what they work with. If you have those economic relations, then there will be economic relations in your economic activity. If there is an interaction between employees and tools, then the work is done, and work has material results. There is work and there are services. And if your economic activity does not combine only that does not combine tools and people, it only involves people, we call that a service. And if it's only tools, then we call it economic activity that's based on property, like renting out or buying and selling. A service is a very abused word. You can't call an elephant a refrigerator. You can do it for a while, but you will run into problems sooner or later. And the same happens with services. From the Roman times, property relations have been sacred. Their stability is a benefit. The elites want it. Everybody wants it. It's all about our tradition. No one is going to extend the legislation covering IT to, say, property relations. Until recently, the telecom ministry differentiated very well between telecom services and property relations. Now, unfortunately, this expertise is lost by the ministry. But I think it will pass. It's a temporary phenomenon. Very well. If we don't like the legislation, is there any way of going above it or outside of it? If our tools are our equipment, and the sense of the economic sense of our activity is the product that the tools produce, then our economic activity of a telecom operator. What does a telecom operator do? Does it transmit the messages? No, of course not. It's the equipment that transmits the messages. The operator services the equipment, just like you have a supervisor, superintendent in your house who takes care of your apartment building. The same here. If you don't like how the government regulates your activity, then okay, you can rent out your networks. The law doesn't prohibit it. Why not? There are two types of rent. The first type is when the person who rents the equipment owns and uses it. And the second time only uses the usage type of rent. It's like when you have a grand piano in a club, and the musician only uses that grand piano, doesn't own it. And yes, there are disadvantages to this approach. The users wouldn't understand it most likely because they used to be users, and now they have to be now they have to be tenants or leaseholders. But it's all a habit, it's all a custom. And yes, there is a legal issue. The civil code says that user lease is possible, but the in a different part of the civil code, we read that our obligation to lease ends with the transfer of the equipment. But this kind of judicial practice says that this kind of lease is possible. Yes, there will be technical issues with connectivity, with connections, but reconnect. But if you should be surprised that those people who will move to the property cluster will win considerably compared to those who stay within the current legislative framework, because you can either buy storage systems and wait till the government decides to force you deploy search engines on them, or you can avoid that. It's all in the eye of the beholder. Truth is in the eye of the beholder. And the same applies to cloud storage, and the same applies to any kind of IT infrastructure. You can't treat a schizophrenic, but you can depart, you can flee, you can exit. And you need a sane mind and you have to have will, and you have to have language, and you have to have vision for the future in order to find the solution. Sooner or later, it will happen. It can happen with you or without you. Remember Igor Maslenikov when he said the paradigm is changing. I think that we are living in a time when paradigm is changing, and the paradigm is changing everywhere, not only in Russia. Thank you. We didn't have time for questions, but maybe we can do it. Yes, sure, absolutely. Any questions answered? Anyhow. Okay, we will have a panel discussion now, and we have a moderator. That's Andrei Kolesnikov. He is the IoT Association Director. And I ask all the panelists to take their place at the stage. And you have some time to think about your questions. Make yourselves comfortable on this shrink's couch. I'm so happy to see all colleagues here on the stage. Yes, Anton and Kazimir. Hi. A very good evening, dear friends. In accordance with our long-established tradition, the tradition of our forefathers and fathers, I suggest that we hold this session in the format to which we have already gotten used over the years of this fora. Quick questions, quick answers. If there is one quick question that requires a long answer, then we'll spend some time discussing that matter. I have a list of questions prepared. Our topic is the future of infrastructure players, regulation as a factor, competition as a factor, and then I will just I don't know, do I need to introduce you people? I don't think so, no. I mean, you know each other very well. I have several basic questions from an internet person. The principle that is being declared from everywhere, the IGF, the other stakeholders, are also saying that this permissionless innovation principle, as it is known in the internet, creativity without permission, without license. Is there anything left from this principle? Does it still apply to this part of the world? Are there still new ideas and innovations in the internet projects? Creativity without permits. It's when you can write an app or code or start a site or start a business or come up with a new business case using the internet. Yeah, please go ahead. Mikhail, you're looking at me so attentively. What does that mean? Yeah, hi. Quick questions, okay? Sure. Yes, I believe that the principle still stands. This is why we look into the future with optimism. This is what's happening right now. I'm happy to be here today. I have never heard such a brilliant summary of the current state of affairs as Vitaly has just presented. Thank you very much. But a logical proposal, like a consistent proposal of, like, again, Anton gave us a solution, a very consistent and a very appealing solution. Because, but on the other hand, that's all we can do now with your revised law. And I had this idea. What about mobile operators? What can they rent? Or what can they lease? Frequencies? But think about WiMAX 5G and drones. And everything that Anton spoke about will work without any law of telecom, and no country will have enough anti-missile units to shut down, to shoot at these drones, low-flying drones. So, yes, I think creativity still moves telecom and the internet forward. Thank you for being so concise. Vitaly, I have a number. In our group of companies, we have a cloud internet provider. So on the subject of business without permission, during the first 8 years, since we wrote these laws ourselves, we followed them conscientiously. And there were like 10 registrations a day because they required passport data, transactions verification. So we did everything by the book, the way we wrote the book. And there was no business. We could get any money. So we said, okay, we'll let customers authorize. We found a loophole in our own law. We can authorize people through a banking transaction. But all our customers now have the same name. They are called Happy Customer. But the number of registrations grew ninefold. Out of this ninefold growth of registration, 90% of them are hackers, spammers, projects without license, but now we have a lot of money. To cut a long story short. Very well. Kazimir, anything to add? Sure. I do have an opinion on that. All these innovations have nothing to do with the internet. It's human nature, which doesn't change. We're not talking about internet, but in the past we could talk in the same fashion at the end of the 19th century about automotive transport. People are people everywhere in all times. Not because the internet is regulated or under-regulated. There will always be criminality because it's part of human nature. Okay. All right. Anton, on your subject, you are good at diagnosing the industry. Some companies today lease out software. Instead of providing telecom and telematics services, they rent out software. Would you call that an innovation? Well, if it is an innovation, it's a bad one, because according to the law, software cannot be leased. We need to find the right solution. To have the right solution, we need to be creative and competent. As to your question, creativity without license, the tougher the legislation, the more creativity there will be without license. That's how things work. Elon Musk's projects, Starlink, whatever the name is, that internet projects, right? As a radio engineer by background, I know that technically it will not be possible to block thousands of satellites. You will not be able to do anything about them. So, yeah, without license. I remember, and I have been in this business for a long time, and I have this person I know, a friend, kind of an acquaintance, in the end of 1970s. You know, the sleds for children, the like sleds, you know, for kids. He used the he used getting satellite TV already in the 1970s using the GAN effect, or bulk negative conductivity diode, GAN diode. So I think pretty much the same. You can do the same. I mean, today you can do the same. No, unfortunately, Musk's the terminal for the Musk's network you'll not be able to do on the back of the envelope, but it can be done. It will cost you about $250. Water will always find a path to drip through. Okay, another topic, macro consolidation in the Russian market. Is oligopoly a threat? Shall we expect a supranational operator for the 5G network and all other becoming MVNOs? Without names. This idea for macro concentration driven by the desire to control everything, is it possible? Is it realistic? Well, it already exists. I don't know how possible it is. There is already an oligopoly in telecom. The Chinese model is very convenient for the regulator, but there will be a phase transfer, Musk and everything. Change of state. Yeah, you can. I can agree with Anton. There is this trend towards aggregation, but you have to understand that the infrastructure is being aggregated and integrated. But content businesses, by definition, will propagate. They will multiply. There will be new ones. Just because we have a limited number of roads, it doesn't mean new devices are not invented to drive on these roads. Can I disclose a secret? Sure, go ahead. To answer your previous question, the position of the Minister of Telecom that can be seen through the tenders that have been organized is that all the money channeled into the regions for the development of infrastructure will be auctioned. There will be a tender, and most likely the person you are thinking about will not win. Most likely the governors of the regions will win. And they will redistribute the money to their own captive small players. So probably, I mean, the execution could have been more elegant, but I think as a result, the oligopoly will be undermined if the minister leaves to see the effect of his policy.
Вы относитесь вообще к идее, когда, например, президент или премьер?
Another question. If the president or a prime minister or a minister instructs an operator to do something, what do you think about this formula? I instruct you. I instruct GLONASS to do this. I instruct somebody else to do another thing. What do you think about those orders? Well, I think it's positive. I don't think that it should be feared. It's a matter of liability. Knowing from inside what's happening, this is not a big celebration when you receive an instruction from the president. You think, why me? What did I do wrong? Why? Because I connected schools myself. It was an excellent project. Yes, it was. But I'm glad I survived. I'm glad I left. I have a lot of people who I know in this room. It's good that you mentioned this project yourself. Remember when Russian schools were connected, the budget was fantastic, and all the liberal community counted every penny and was afraid that the money will be lost and stolen. Anybody in the room believes that it was in vain, like the money was wasted? There is one person. Oh, well, Sasha, I know you. You don't need to raise your hand. I know that the way you will answer. But you asked the right question. I want to answer it. Is it a good thing or a bad thing to receive an instruction from the president? Yes, it's a good thing because we know who is liable, who will be responsible for this project. I know that Minister Raymond Merkel and Ms. Reding, she was head of European Commission, subcommission for IT. I went for a bicycle ride with her. Okay, good. You know who I mean. And Merkel says, how do you connect schools? And Raymond says, we appointed Smertnik, he will do the connections. And Merkel said, And we organized tenders twice in our regions. They stole all the money. And on the third time, we appointed someone, and the project was completed finally. Sasha, I will give you the floor. Don't worry. And during Medvedev's time, more than 2,000 schools. And I'm sure that Sasha will give us the numbers, but we all received 3 billion rubles for 2 years for more than 2,000 schools. And according to current standards, it's peanuts, it's nothing. And that was 2007 during Medvedev's rule. Oh, I'm sorry, not 2,000, 52,000 schools were connected, 52,000 schools. Okay, when an executor wants to get a contract, wants to get an instruction, wants to be instructed, like goods labeling, for instance. I think Anton and Mikhail know about it. If there would be liability and people will be held liable, why not? If there are volunteers, why not? I would welcome volunteers. If the volunteers give me informed consent that they know about the criminal code articles applicable to... There is this fashion among the government officials in the regions. They steal, in a very stupid way, they steal the money to their personal accounts. And when they are sent to prisons, the investigators ask them, why so primitive? And they say that, okay, I stole 5 billion. I will get out from prison. In 5 or 6 years, I will have 5 billion. But if I do not steal the 5 billion today, what will I have after 5 or 6 years? Digital economy. We will have digital economy. He will have digital economy. I will respond to Anton because one of my hats is a delegate to the regional parliament representing United Russia, the main political party. I'm on the other side of the barricade, so to say, for several years now, and to tell you what people think about the government looks differently from how the government looks from inside. If there is, a mug of beer and you see foam at the top, but you don't see what happens inside this mug. What's inside is ungrateful work, especially in the regions, but you don't see it. But it's very nice to complain and to scold or berate the government official. So I'd suggest that we need to maintain a balance. The government to the population, it's like a family, it's like parents to children relations. If you look at that from that perspective, then everything that we do when we are misbehaving and when the government allows us not to wear a hat in the evening and we get sick, well, I'm not. So whose parents and whose children? I think the government is a child who the parents, the population feed and everything, and it's the government that doesn't wear a hat in the evening just to offend his mother. And by the way, any human from inside looks differently than a human looks from the outside. Right, okay, Mikhail. We have a pie, a limited resource, and we want to share it. I know all kinds of limited resources there are in the world, like spectrum or access to infrastructure or numbers, the numbering resources. From your point of view, if you look at 2000, when internet was in the stage of being erected, being constructed, and end of 2018, end of this year, access to infrastructure, to the spectrum, to limited resources, is it still a problem? Because in the past, we used to have a lot of issues with access to copper or to the sewage system, whatever. Today, are there any islands of of resources that are hard to get access to. Well, my career was rather sinusoid. I started my career at the telecom operator. After that, I worked at the government for a while. After that, I went back to the internet, and now I am working again at a telecom operator. And everything that I've been observing and I am observing now reminds me not the year 2000, but rather middle 1990s, but at a new stage of the spiral. New problems, new questions, but unfortunately under the same limitations and subject to the same challenges and overcoming those limitations, like the conversion of the a spectrum. Everybody wants the frequencies, everybody wants the spectrum, new ranges, same questions, same problems that we had in 1990s. The scale is different, it's bigger now, but at a systemic level, and Vitaly spoke about it already, we tried to do something and we did a lot, but even the things that we managed to achieve, unfortunately, did not suffice. And we should have done more. And here the government should play a bigger role. One thing is to think about the future of the country and the future of telecom and to lead the conversion and to buy equipment that does not operate in the commercially used frequencies. And on the other hand, there is corruption, which is the reverse side of this coin. Well, you are so complicated. I mean, your answers are always so... so rounded, so streamlined. Well, actually, today I think that we are not thinking about this as a big problem because there are fewer contenders. There are fewer contenders to their share of the pie because we now live in an environment of an oligopoly. Going back to Rostelecom's sewage system, to a large degree, the matter was resolved. Yes, it was. Yes, it was resolved, but it did not, because the price of a meter is 7 rubles, and 7 rubles is not cost efficient. So that's what Mikhail spoke about. So yes, there is access. So yeah, you can use it. I mean, the resource is there, but the business case doesn't stand. So I agree. It's a spiral. We've reached a new level. And it's an oligopoly, fewer contenders, fewer stakeholders. Okay, the role of the government will leave it for desserts. But let's talk about threats for a while. Anton, it's what you mentioned. This... I mean, very often in justification for the government policy, an argument is referred to, which is the argument of enemies, but there have always been enemies around for thousands of years. Selling threats, I mean, not trying to get money for the threats, but bargaining with threats, selling solutions to the potential threats. This business, has it grown in the last 10 to 20 years? Well, this is classical manipulation. Psychologists know about it very well. There is nothing new there to develop. Well, yes, it's very developed. It's very mature. But have we reached this stage of saturation? No, but the sky's the limit. No. It's a post-modernistic thing. It can evolve forever ad nauseum. It's the Maslow's second level of needs. I mean, security is the second level Maslow need. You can sell it forever. And what I said, this indirectly refers to the government. The government does not sell anything to anybody. It's how the government subconsciously understands itself. The government doesn't have the mind or a conscious. It has subconscious only. And the government, the state, is schizophrenic. Not just Russian government, any government. Maybe, I mean, sometime in the future we'll learn how to treat this malady, but not now. Okay, another question. You must have read the Digital Economy program, and it contains 2 big sections about infrastructure, the development of the digital infrastructure per se, and there is a big block on security. When you read the document you see on the left page one thing, and on the other hand you see the opposite. And it's for a doctor. It's not for an engineer. It's a document for a doctor. Here you read innovations deployment, and on the other hand you read immediately about control and restrictions and this. How do you test for the health of what is the parameter of health of the government and of the society? Can these things match somehow? Well, health. You mean the golden middle between schizophrenia and psychosis? There is this. What's it called? The split mind or something? What's it called? Split brain? No. The health is in the middle. Health is in the middle of this spectrum between psychosis and schizophrenia. It takes time to answer your question. It only takes time. Telecom is still new to the society, and all these fluctuations, the conflict between the public and the private, the society is not mature. We have not absorbed IT yet, just like the society has already absorbed cars and TVs, but we haven't absorbed the internet yet. I think it's a matter of time. I will disagree with you. I do not think that there is a conflict. I think it's some kind of a sandbox where, minor ripples take place. There are no evil genies and good genies. They do not exist. It's not fighting until death between the proponents of progress and the evil genies that want to control our every step. I don't believe in this controversy. It seems to me like it's a fuss. Why you say it's a fuss? It's not fussing because it affects the society. When I said conflict, I don't mean resistance. I mean very often misunderstanding or not enough understanding. Like there is a misunderstanding, misalignment between the government and the market stakeholders. It takes time to resolve this misunderstanding, like ROA's law, when we were first frightened by ROA's law and where we are today. This is a good scenario of how things evolve. Since you mentioned this law is not enforced, kind of. Well, as an operator, a long-standing operator, I can tell you that there is practical communication with the supervisor on the part of the government, and on the other hand, there is a mass media that talk about it. And those two processes do not correlate very well. What's been said about the ROA's law and what's been done, they are two different processes. What are we talking here about? That's exactly the problem of this business. Very often, what's been done differs from what's been said, and very often our internal, processes matter more. Is there? Yeah, speaking about criteria, there is just one criterion, which is individual freedom. The more there is individual freedom in economy and elsewhere, the more people can do to release their creative potential, the better off the economy. If we declare a digital economy, then to me, individual freedom is the key factor by which we can decide what's good and what's bad. The only thing is often legal technology is not often used for the development of the economy. We know Singapore, for instance, right? Very advanced country, and they are doing well in terms of digital technology. But the economy of Singapore is not based on digital economy. They use the geography, they use the financial capabilities. Digital technology for them is an enabler, just like for China. They're using digital technology for other purposes. So when we talk about the Russian digital economy, information security and everything program, we must understand that it's not about economy. Yes, I heard very often repeated that economy is digital by definition. What is analog economy? I don't know. Well, if there is digital, there must be analog economy. What is the analog economy? Tanks, maybe? Tanks? Light bulbs? I'm constantly discussing this whenever we talk about regulation with the legislators, digital, non-digital. To give you an example, everybody today has to have a driver's license, which is a card, a paper card. And there is an idea now to introduce an electronic document. Yeah, biometric. We start describing the requirements of electronic document, which electronic signatures must be used, what FSB's role is, what cryptographic algorithms must be used. We start transposing into the digital environment our requirements to the paper documents. This is not digital economy. A policeman stops us, we give our name, the policeman on his screen looks. You don't need to even introduce yourself. Okay, fine. But we are being identified, say, by our name, and then the policeman knows which car I own, what license I have. This is digital economy, but we are still discussing encryption and digital signatures. Oh, Mikhail, I know what you're talking about. I talk to students often. I read lectures about digital economy. We are all flooded in paper. There is the insurance, there is the passport, there is the driver's license. Insurance companies spent billions from switching to pink paper, to blue paper, to violet paper. But you need an RFID chip on your car, and that's it. That's it. And you don't need. This is digital economy. Or bank cards. Bank cards. They will die out, I think. I know how to do it. I know what we can do. I know what we can do with the government. We need to create a test zone. We should take a police car and in this police car, whenever a car, normal car, passenger car, passes by, the policeman sees everything about this passing by car. Right. Anyway, I mean, we all have irises and fingerprints and everything. I mean, this replaces all the endless paperwork nicely. There is this lady. She works as the chief IT officer of the Russian tax inspection. She says, without electricity, we are nothing. For the archaeologists of the future, who will be, restoring the history, nothing will be left from us if we are all digital. Nothing will be left of the tax service. I want to go back to Alexander's presentation. When I have a piece of paper confirming my rights, I have it. If I have a record in a database, it may not always be available, going back to big data storage and SLA and all of that. When we have this piece of paper in our pocket, cash, I don't know, or a document, we have them. When it becomes digital, we become dependent in routine issues on third parties, and very often it's not third parties but fourth and fifth parties. So this transition to me doesn't seem trivial. I understand that we desire to make our economy digital, but going back to your presentation, we do not have resources to ensure reliability in the virtual world that can be ensured in the physical world. It's a matter of principle. We all love cash. Blockchain may be with you. Right. This is exactly the difference between analog and digital economy. The economy doesn't go anywhere. The economy stays the same. There are countries where people prefer big vehicles, big cars. There are countries where people wear all the gold that they own on them just to show off. And there are other countries where people are driving Fords or whatever, Kias, but everybody knows that this is Bill Gates or it's somebody else. Like 200 or 300 years ago, Russia was among the countries that preferred to wear all their gold on themselves, but we no longer do it. The countries that do not showcase their riches protect property rights very well. They know how to do it, and everybody is certain that their rights will be protected by the government. I have a castle, I have a big land plot, but I don't need a big signage, a big sign stating that that castle or land belongs to me. But in other countries where property rights are not protected, you have to wear your gold on you. When you get a divorce, you mean the woman has to live with all her golden rings on her. But I mean, there are many countries. It's about protection of your property rights. There are countries where you can board a plane, like New Zealand, without presenting the documents, or in Australia, you can board a plane without producing any paper ID. It's maybe an extreme example, but it is a good explanation of the differences between digital and analog economy. There are countries where property rights are protected. Even if I lose everything, I will be able to recover my property using the records in the databases. And there are countries where we are afraid to lose our paper IDs. My mother once lost her land certificate, land ownership certificate, and she was in panic. And I was telling her, no, we have the records in Rosreestr, in the national database. Yeah, we no longer need the paper certificate. Exactly, that's what I was trying to explain to her. You are a record in the register now. And she says she's a very practical person. If the register breaks down, how will I be able to prove that I own this land? Or if her record is substituted by another one. I was not talking about property rights. I was talking about the technical implementation. If you know how the system, the storage system is set up, you will know for certain that you'll be able to maintain it, or you will not be able to maintain it. I don't know. And people, we work in the industry, we know it, but laymen, they trust the government, and if the government commits to store the data, then technically the government should have the capability. But in Russia, all this technical capability comes from abroad. It's imported. Well, not everything is important. Alexander is sitting between us. I know for sure that he knows how to store the data because he's been storing the data for many years. Okay. One other thing. I think it was today where at TLD website, I mean, the statistics was published and it showed an increase in TLS certificates. It all happened in 2018. We recorded a growth in TLSSL certificates to sign the sites, and basically the exchange of traffic between the client and the server is encrypted. This trend is unstoppable and irrevocable. It's a global trend. I have a stupid question. Yarovai and Sorm. So this traffic is 100% of it is encrypted. What do you do with it? I mean, not you. I mean, people in the law enforcement. What will they do? Will they wait for the quantum computer? The traffic is encoded anyway. Does anyone know the answer? I have already given you the answer in my presentation. No one is going to do anything about this encrypted traffic. All they want to do is control. You can't find anything in this traffic, even today. But if you want to decode it, decrypt it, then another law will be passed to decrypt it. The problem of the cornerstone of legislation is a report. It doesn't matter what's written in this report. But the important thing is to have the report. You know Telegram, you know it's blocked, you know that there are people in this room using Telegram. Anybody uses Telegram in this room? Excellent. This is your answer. Officially, Telegram does not exist in Russia, and yet it exists. I don't know, maybe there is some sacred knowledge. There is no sacred knowledge. It's all plain and straightforward. Nothing will change. And it's not typical for Russia only. It's typical for any legislating state. There is a law and there is a report on its execution. That's how any government service is structured. Otherwise, there will be chaos. Or there is the other empirical methods which we use, and empirical. How did you call it? An empirical. Empirical crawl. Empirical crawl. Okay, I'll try to remember it. Anyway, like ROA storage. Those who are supposed to execute to implement this law have never supported it. And mostly people found themselves in a situation when there is a law and they must perform it, but they are doing something, but I don't think they even understand what it is that they are doing. I'll give you another secret. So the idea is not to collect all this data, be it encrypted or decrypted, whatever. The problem is in the SORM terminal algorithms. SORM collects a session, yes, collects some information from it, yes. And right now, there are no algorithms. And it's a fact. And American colleagues, I think back in 2006, closed the last storage, like in Alabama or in Lauderdale, I don't remember where. They had the storage system which collected all traffic, period. And something similar was closed off in London Internet Exchange, because all these crawlers that trace exabytes of storage trying to find something. I mean, they couldn't even collect WhatsApp sessions or Skype. It was a Skype session. They could not get even the Skype session. They said, "Okay, thank you very much." So since then, they've only been storing metadata. Well, metadata, I understand. Exactly. But when you see it in some high official's office, and you learn about only you know the results, knowing who spoke to whom. Okay. So we are building now virtual government borders. This applies not only to Russia but also to Europe with a wonderful piece of legislation from May. It also applies to the Chinese arrangements, Russian arrangements. So all this story, are we looking at the internet fragmentation, or that's just paperwork? Will it affect the user? Maybe the users don't care. We are fighting to the first blood here, referring to ROA and GDPR, but the users on Facebook and VK just don't care. Is there any connection between internet governance and virtual borders and self-protection and propaganda of Western values, and the user doesn't care? He hasn't noticed. Maybe there is no direct correlation between the global processes that are trying to erect walls everywhere and the actual human being in Kansas or Syktyvkar. The users are okay before they are knocked out. Since I work with different jurisdictions online every day, I can tell you that every state today and every jurisdiction today operate in the same fashion. they make choices. When it's good for them, the jurisdiction is where the server is. When it works for them better, the jurisdiction is where the user is. The Google text is a good example of that. Border online or in the internet is a topic that nobody wants to discuss because we don't know how to discuss it without calls to limiting anybody's sovereignty. Nobody knows how to discuss it, neither in Europe nor the United States. When the government wants it, you will be under its jurisdiction. When the government doesn't want it, you will be outside of its jurisdiction. If you look at 5 key DARPA priorities, like areas of development, either at number 1 or item 2, you will find digital data genetics. So yes, they are working on identification and origin and migration and who slept with whom and whose jurisdiction it is. And in this top 5 for them, by the way, ladies and gentlemen, telecommunicators, is common shared spectrum, getting rid of the licenses that would be individual to the telecom operators, but instead offering a single spectrum in all bands for 5G. It's another DARPA priority, and they're supposed to present a solution in 2019. On the subject of jurisdiction, like let's think back 500 years, how you could have exited the jurisdiction, who could have exited the jurisdiction. Traveling was extremely expensive. You had to have a lot of money to move to a new place. And after that, there was navigation and sea voyages, and the quality of life improved, and people started to have more opportunities to change the jurisdiction. Then there was air flight and road traffic. The internet lowered the possibility to change the jurisdiction by several times. In order to overcome the barriers, we do not need to migrate for life to Israel, to the United States, buying a ticket to an airplane. You can do it at a lower cost without leaving your house. So today, jurisdiction and digital sovereignty is understood incorrectly, falsely. New ways will be found to bypass those concepts, and at every next iteration, those bypasses will become cheaper and cheaper. So whenever you mention jurisdictions and sovereignty, you have to be careful. And I think that already today the world is quite flat. It will become flatter, and most users will just not recognize jurisdiction. The users will not recognize sovereignty. Users will stay with cats and dogs, and they will always have the money to use, say, Telegram from a different jurisdiction. I spoke about that already. If you migrate both alone networks and alone jurisdictions at the same time, that's what Durov did. No state will be able to catch you. If you are migrating only on the networks, if you are a content provider, you'll be found. If it's jurisdictions can talk to each other and they will come to an agreement. But if you do both, nobody will be able to catch up with you, at least for now. Colleagues, maybe you have questions to each other? Because we're supposed now to switch to questions from the floor. And this flat world, I agree, is that's in the process of being shaped. But the problem is we are not controlling the process. We are not controlling it. Russia is not controlling it. We are not controlling it as operators. It's controlled. The process is controlled by other states and operators. And those operators will then control this flat world. When talking to friends, they say, I'd rather prefer to be controlled by someone 5,000 kilometers away from me than someone who is living next door to me, That's exactly what I want to say. I've just been talking to Vitaly. In the flat world, why do you need control? And why do you need controllers? If you feel like the internet is under control and Russia is not a big player and I agree with that as someone who spent years in internet governance at a global level, but who's to blame apart from the Russian representatives in the process? When I was an official of the ministry, I pushed, and Vitaly worked with me. Yes, exactly. We pushed hard to ensure that we become part of the global internet governance process. And the only ministry that was interested was the Ministry of Defense. They were the only interested party. Everybody else ignored it. And now suddenly we find out that somebody manages us or controls us. It's not true. Colleagues, who was the first to raise their hands? Hi, my name is Alexander Isovny in the Internet Protection Society. Anton, I want to be able to come to TeliaSonera and rent a gigabit to Sweden. When can I do that? There is no TeliaSonera. Whoever you represent, Telia company, where are the sales managers here? I would love to sign the contract right now. Maybe go talk to them. No. Can I help Anton out? Sintera. Remember Sintera? I think there will be several people in the room who remember the times. Do you remember the project? The WiMAX mini networks? Do you remember? I promise you, 60 contracts without licenses, without spectrum, without nothing. No, I'm not interested in the old Sintera project. I'm interested now in TeliaSonera. I want to trust yeah. And also, people who write laws and people, the technical specialists who say that, no, we are not about politics because we are about technology. I want the revised law to become the Darwin's Prize for you. I think that we'll all go to hell for this. Well, them first. No, it will not work like that. On the 1st of January 2019, when the jurisdiction changes, if the jurisdiction changes, there will be big problems with change of jurisdiction, and there will be many companies will have big problems, especially Russian companies. I don't understand why we are not discussing this today. What I mean is, on the 1st of January 2019, an amendment will come into effect into the tax code. Any foreign legal entity providing digital services, including co-location, hosting, clouds, domain registration, and it's a long list, will either have to become Russian tax agents to register here, or they will suffer. Well, they will not suffer, but we will suffer, because RIPE, ICANN, safe names, and it will be a long list of others. They will not register as tax agents here in Russia. As a result, everybody who uses electronic licenses, who register domains in foreign jurisdictions, RIPE, currently RIPE is definitely subject to this law. They will all face a problem of either taxes in Russia, big taxes in Russia, or most likely during currency control, the payments will not be let through to their accounts. VAT. So consequently, a question to everybody: what do you think about that? What will be your recommendation to a long list of companies? What do we do? Lyosha, I actually studied this question. RIPE and others objectively face no risks. Will they register or not? Well, actually, it's a big question mark. I think most of them will prefer to register. As to currency control, there is already an explanation from the tax service. It's VAT. You cannot write off your VAT to those payments. You will be able to make payments to them. So I don't see big issues for the Russian businesses. No, you are wrong, because we too carried out the research, and we were told specifically the currency control will not let the payments through. With respect to RIPE, there is a solution. Yes, but it's not just RIPE. It's ICANN, it's safe names, and the long list. As a representative of RIPE NCC in this region, let me say something on our position. We are working on it 7 years ago. At the request of our members, we changed the the description in our invoice from membership fee to service for currency controls purposes. But now we are going to change it back to membership fee because it is a membership fee. And for RIPE and CC, it's a solution. As to everybody else, I'm not sure. But with respect to RIPE, it's going to be fine. I want to talk to Anton. We're from ReNet. My name is Timur, and I am the ReNet internet provider. I remember 2006, and I remember this conference, and you talked to a room full of providers, and you said that we should not pay to DESIS and OK because if you start paying them, they will start milking you as a cow forever. In practice, things got better. There are fewer payments to DESIS, and it was a Moscow-based meeting, Moscow conference. Now you said it would be worse, but actually it turned out to be better. No, wait, Timur, let me answer that. I'm very glad I was mistaken. I would be happy to be mistaken like that every day. Another mistake. It was a private conversation. I asked, why now you work for a big corporation? You said that independent providers are facing the music, and that was around 2010, I think. And I'm looking now at this room, and I'm seeing a room full of independent providers. Independent from what? I don't know, M9. I don't know. Can you tell us that you are losing members? Independent. What do you mean by independent? There is private business and there is independent business, and these are two different notions. I do not believe in independent providers. Yes, they are private, but any independent provider is not actually independent. They haven't merged with anybody. Independent is, well, yeah, they are not merged. Okay. They haven't merged, nobody merged with them because probably nobody needs them. But maybe the government schizophrenia will somehow, it will treat itself in a way. It will kind of go away. And I'm just thinking that things are not that bleak. Well, schizophrenia is not treatable. Timur, do you keep Yarovaya everything full volume? There is nothing to store. Yes, there is something to store. You haven't read them, Timur. Are you complying with the Yarovaya's law? So the principle is, before they put a gun against your head, you don't need to do anything. Yes, but when they put the gun against your head, it will be too late. Thank you very much. Yeah. Oh, another one. Yes, please. To sum up this discussion, and what I'm going to say next is my personal opinion, and I came to this industry back in 1996, and I, for 8 years, have been working as someone in the government, in the regional parliament. So, my whole career today spans 27 years, and from experience, I think we are our worst enemy. We can't blame the government. We can't blame Rostelecom. We should blame ourselves. We were the ones who lost to ourselves the margins. We are the ones who lost ourselves the opportunities. But the users won. Well, we are operators here. There are no journalists in the room. I am not an operator. Can I say something in conclusion? Today I work at Wimpelcom. And many of the questions that were discussed today are constantly on our agenda. I've been with Wimpelcom for the last year. So I still retain this critical view as a newcomer, as an outsider almost. I understand that we live in difficult times, but what times are not difficult? We live in exciting times. We do everything we can to make sure that our customers benefit from what they do. And yes, there are certain negative trends, but we have our capacity and we have our frequencies, and we can use those resources to offer new services that will be in demand. So we believe that the telecom operators have the future, and definitely we will resist every attempt to establish an oligopoly. And I agree with what others said, that our government today will not let it happen, judging from what the ministry is doing, judging from what the antitrust service is doing. And again, it will be exciting, although it will be challenging. It's great that the number of small operators is growing, or small providers is growing. And yes, there are only 6 mobile operators, and 4 of them are known to everybody, and 2 are big regional companies. And 95, I don't think that we had more than 6, but they were weaker, definitely. So today we live in the time that reminds us of what we had in the past, but we are at a new level, and I'm sure that after 20 years, 10 and 20 years, we will come together again and we'll discuss that again. Thank you. I want to thank all the participants. I want to thank the audience, the listeners and the viewers. Thank you very much. Okay, very well. Different points of view. We'll thank all the panelists for sharing their perspective on the topic. And there is only one announcement left to be made. Everyone is invited to stay with us for the evening reception. If you were listening to the translation, please do not forget to return your devices to the registration desk. Thank you for coming. Please be back here after a year. Thank you and enjoy the evening.